think we're live now. Okay, so cool. All right, so no one's on just yet, but if people do hop on. Go. All right, come on, chat up now. All right, cool. So for anyone watching this after the fact, I've been playing around with a new little game engine that I wrote up. It's not really a game engine meant for deploying stuff. It's more a game engine for being able to teach stuff. So it's pretty lightweight. Basically, it has sprites to render. So a sprite's just anything that shows up on the screen. We have a couple different flavors of sprites. Text sprite for showing text. Parallax is for creating those backgrounds that keep going forever, like this background here. Image sprite shows an image, and then game sprite's a special flavor of image sprite, which basically has a little bit of minor physics movement on it, so you can set some velocity and acceleration, and it'll move every time you tell it to move, every time you call move. And then render manager just basically loops through renders them. Then we have input manager, which just basically keeps track of our inputs. So we got keyboard and mouse, and then I recently discovered there's now support for gamepads in browser now. Not sure when they added it exactly, but it's pretty cool. So I'm moving around now with my gamepad, so that's pretty neat. So I threw that support into my input manager as well. Still track mouse, keyboard, and gamepad. And then data is literally just for storing data across the scene. So I use it to, when you die, to transfer this score over. And then we have our scenes and scene manager. So a scene is basically just any like state of the game. So this is the game over scene. This is the start scene, and then this is the game scene. And so they're generally completely separate from one another, other than the data manager and scene manager are shared between them. So you can use data manager to send data across. And then util just has a handful of little utils, and then I haven't done anything with sound yet. So I'll push this code up after I'm done streaming. I just have a console log. Let's kill that console log real quick. Where are you, console log? There you are. Alright, so made this little demo game. Move with the up and down arrows, or you can use gamepad. Left stick moves, A fires, and basically it's your very simple space shooter. So you move around, hit A, shoots your bullets. That's pretty much it. You got lives up in the corner. Once you lose enough, game over. So I'll push this up as just a demo, and then I wanted to start a new game here that'll make use of the engine as well to kind of go from the beginning with it. But before I dive into that, I wanted to share a cool new workflow when it comes to creating images that I discovered. Sorry, hang on one sec. I just realized I can't see. Okay, there we go. I just wanted to get who's in my chat up if anyone joins so I can say hi. So I discovered a new workflow with Photoshop. Well, new to me. I'm sure it's probably been around for a while. Let's show an Explorer just so I can open this guy up with Photoshop. Okay, so before, what I've been doing for a while now when it comes to my images is I'll usually, where's my layers? There it is. I'll leave it there. Is I'll make one image per layer, and then I would do export, export as, and export my layers. Which actually, did they move that? I don't remember. No, yes. Now I think that's in Legacy. Save for Web Legacy, I think, is where it's at now. Somewhere. Maybe it's Save As. I don't know. They moved it. But anyways, don't need that anymore. Oh, there it is. Layers to files. That's what I was looking for. So that would output layer each. So there's this thing that's generated. I think used to is like a thing you had to enable, and now it's here by default. But if you start up a new document and you come in here and generate and hit this, whenever you save, it automatically will save as long any layer that's named like a file name here, like background.png or layer group, like this guy will become one file. It'll save all of these when you just save the Photoshop document, and it puts them in a folder that's named whatever your document is -assets. So if I open up this guy, we have you can see demo assets right here, and so you can see here's all those images. And I can even, just to show you, I'll delete it. Come in here, just make a superficial change of something, doesn't matter what, just so I can hit save again. There we go, I moved it. I hit save and it generated all those for me, or not. Hang on. Apparently it only generates the one that changed. Generate. Let's check it. Save. No, we should have all of them. There we go. Okay. So, but yeah, so this is cool now. So like now my workflow is just if I want to make a new image, like say I want to make a title image that we can throw into the title. I can just come in here now and I can be like zoom in a bit so we're at 100%. I can be like, yeah, I don't like that. Been using not that guy. There we go, that guy. Shooter. We'll call it Space Shooter. I should probably pick my tablet up off the floor and use that instead of my mouse. Space Shooter. There we go. So, on my new thing here, I just hit Control S to save, generate a new title image, and now I can just like throw it in my scene here real quick. Gotta load it. Create a new title sprite. Title.image. Oh wait, hang on. That's not what I thought it was up there. Wait, image sprite. Create from URL. Assets title.png, and we'll set the origin to the middle. And we'll set X to the middle. And we just add it to the root sprite. And there we go, Space Shooter, yay! So, but yeah, I really am liking the Photoshop, the new Photoshop workflow for me. Makes it a lot easier. Now I can just, I need an image, pop over here, draw the image up. Obviously, they're pretty rough images, but I'm making games more so people can learn rather than so I can publish them. So, alright, so now I want to make a new game. So, what I'm going to do for now, just because I don't have it set up right, is I'm just going to throw the new game. Let's do this. Well, let's make a new folder in here. I'll split the game we're about to make out into its own repo when I go publish it, and I'll publish the engine 10 p.m. so you can just import it. But for now, that'll take a bit, so we'll just do this real quick. Let's make a new folder. And let's make Let's actually rename this guy to Space Shooter. Rename Space Shooter. Oop. Or not. Why can't we? Why can't we indeed? Curious. Apparently something's holding on to it and won't let me rename it. That's weird. There we go. That was weird. Sorry, let's mute my notifications. There we go. Okay. So let's grab my tablet real quick. Tablet. This way. And pen. Jeez, I don't use my tablet enough. It's covered in dust. Alright. Let's see, it seems to be working. Not oriented right. Let's see here. And I want none of those. Get me out of Photoshop. That's not what I want. Where are you? Not that. Not that. Give me that one. Let me change my settings real quick. I want it on the right because that's easier because I'm left-handed. And I want it on just monitor 1. There we go. Much better. Okay, so let's make a new file. Let's make it real big. Should be fine. Okay, so for our game, well, make a game where we have our character in the middle, and our character can shoot a weapon, and they can rotate all around, and enemies will come in from all different ways. We'll say they're zombies. So, zombies will come in from all sides. We can rotate around, and we can also move around the screen like this. And we'll have lives and a score. Okay, so that's going to be what our game is. So let's go ahead, pop back over to here. So we're going to call this, we'll make this Zombie Shooter. Zombie Shooter. Hang on one sec, let's see, can I change my Wacom settings so it keeps reacting to every time I put my hand on it. It's touch sensitive right now too. I want to turn touch off for a second. Pen, can I disable touch? How do I disable touch? Disable, no, that's buttons. Pen and tap the pen to make right click, hold click. Nope, alright, to the Googles. Wacom Intuos Pro M disable touch. Turn off, use the slider switch next to the, oh right, I forgot, there's a little switch over here. There we go. Alright, there we go. Now every time I accidentally touch it, it won't go crazy on me. Okay, so, Space Shooter. So, for our little engine here, I have just a really tiny node server over here as well running that serves up the assets and stuff. So I'm going to point this guy at demo zombie shooter. That way you'll pick up the index.js from my zombie shooter. Okay, so what we're going to do in this guy is basically we'll create an instance of the engine. Azure engine. Okay. And then, so that'll create our scene manager and blah, blah, blah. Then we have to register our scenes to it. So let's go ahead and make our start scene to start us off. So start scene. And our start scene is going to extend scene. And I've given the scene a handful of different calls that it comes in. So there's one initialize when it first creates. Then there's enter, which is triggered every time you enter. So like if you leave and come back, that's an extra enter. Exit is when you leave it. And then tick is every game frame rate, game loop tick that'll trigger. So kind of this is for one time and you're done forever setup. This is for setup each time you come back to it. This is for cleanup. And this is to update in between. So for our start scene, so start scene is basically just going to be, I'm just going to fill this with white and draw over it on a new layer. There it is. Paint bucket, white, white. Okay, so start screen. Brush would be nice. And not white would be nice. There we go. Alright, so we're just going to have title here. So just a graphic. And then we're just going to have a start button here. Start. So, pretty straightforward. So, for this guy, remember we have the 4 possible states here, or 4 possible actions. So, and each one of our scenes has its own root sprite, so its own screen. So if we attach something and leave the screen and come back, it won't get unattached. So we don't have to reattach every time. So really, pretty much creating this sprite and putting them in here, we're just going to have to do once. So we can do that on initialize. And really, that's it. We're not going to have really any tick things unless we hook up controller to do start, which we'll do later. So let's just do initialize, and we don't need super initialize in this case, and then we're gonna keep hitting Wacom buttons. So let's make a title. Well, let's make the images first. So let's go make a new Photoshop file. And that's fine, doesn't matter what size it is. So I'm gonna make a blank one, get rid of this white background. Okay, we'll go ahead and save it in the right spot. I do not want to save in your cloud. So I'm gonna call this zombie.psd. And so that'll save all my individual images into zombie assets. So let's go here real quick to the server. We're going to point this guy at zombie assets instead. And again, like I said, I'm going to pull the zombie stuff into its own repo, so if you pull this down later, it'll be hooked up to demo and zombie will be in its own thing. But for now, we're doing this just so it's quick. Okay. So first up, we'll make the title. So title.png. Gonna zoom in to make sure I'm 100%, because that's what the real size is gonna be. And I'm just gonna make something quick and ugly. So let's just we'll do zombie greenish color, and maybe something like that. And we'll call it zombie shooter. Okay. Yes, whatever. And the nice thing about, when you're designing a game is you can get away with quick little, even like if you're planning to actually, put polish on it, you can get away with creating quick little dummy images like this. And then you can always come back, and once the everything's in place, you can then, start swapping out proper images. So, um, yeah, so got our zombie shooter, so that's that title. And then I always lock the layer after I'm done with it, just so I can't screw it up and accidentally draw on it. So that's that. And then we're going to do start button.png. Okay. And so why don't we stick with the green? I'm going to make this a little bigger. And I'm just going to kind of do like this, I think. Okay. And actually, this guy will have the text separate, so we'll actually group them together. So let's name that start button. And then we'll just put that in there. And I don't actually know if he'll create two or not, but I'm going to change the name anyways. Okay, so got the start button. Let's get some text. Come on. And let's see. Anything jump out at us? Let's do... What is that? No. And there. That's some. Okay. Let's say start. And it's green right now, which is why we can't see it. Let's make it white. There we go. And we'll get it centered. Go. Okay. And so how I actually made the image sprites is they can handle mouse events, and they can actually, they'll automatically flip between three states. The regular image, which you're not doing anything to it, a hover image, and then an active image, which is where your mouse is actually down and you're clicking it. So let's go ahead and we'll just clone our start button. And actually, let's do this instead for this guy. So on the demo, I just kind of color swapped it. For this guy though, why don't we do a shadow? Real kind of quick, hacky shadow. Let's go with not quite black. Well, we need to actually do an adjustment. And we'll do color balance, not color balance. Use saturation. And take the lightness down. And take the saturation down. Take the lightness up. So saturation is how much of the color is in there. So if I have it normal, then it's still green, and then as I take it down, we go gray. And then lightness is how bright or not it is. So we'll take that down like that. Swap the layers out. There we go. And the snapping isn't letting me go where I want, so I'm going to hold control down. Go and actually, why don't we do it there? Alright, I don't like that one. Let's use the blending option shadow instead. Blending options. We want a. There it is, drop shadow. Nope. Okay. And let's get our angle. Actually, that might be what I want. I want it kind of underneath it. And distance. Let's increase the distance to there. So we're going to start with the button kind of in the middle, and then when we hover, we're going to make it move up, so the shadow will kind of get further away. And then when we press down, the shadow will get closer, like we just shoved it down. Let's see, size. Want that small. Let's crank up the opacity because that's a little too unnoticeable. There we go. Okay. So there's our regular state. And then rename this guy to start button hover. And right now they're stacked on top of one another. So I want to move both of them. And I'm going to uncheck auto select. If you have that checked, they'll automatically figure out for you what you want to move, which won't move the group because they'll just pick one thing. All right, let me check that. Okay, so this guy, let's go here. We're going to edit the blending options again. And we're going to basically just increase the distance. So, no, come on, drag. And let's go like that. Okay, so that's hover, so that's coming up. And then duplicate one more time. Active. And this guy, edit this, and we're just going to take the distance really small, pretty much almost off. Move it. That's probably good, and they're still stacked on top of one another, so uncheck that. Move that. There we go. Okay, so we got our three. Let's lock them so I don't screw them up. And we'll hit save, and now we should have a folder over here called zombie assets. Oh, nope, we don't, because I forgot to come in here and hit that. Alright, now we save. Now we should have assets. There we go. Cool. So let's go check out our server. Zombie assets, yay. Okay. So now I'm coming to our start screen, so we'll do title equals, and then I have a create from URL helper static method on image sprite. And it's async, so we want to make sure to do await on it, which basically means, so async operations, something that kind of happens on its own time. So like normally if I had like an async call and then I have some other call down here, the async call wouldn't necessarily be done yet. But in JavaScript, you have await here, which you can use in any function marked async. And if you do that, then it will actually wait for it. So it's going to wait to create this before we move on. And then this guy takes 3 parameters, URL, hover URL if we want an active URL, which we do. So all of these paths are going to be assets because that's what my server serves them up as, and that's what the browser is going to see. So even though they're in the zombie assets folder, my server handles that translation. And then we're going to do startButton.png and startButtonHover.png and startButtonActive.png. Okay, wait, sorry, that's for our start button. Do our title real quick. I always like to work from top to bottom when I'm doing anything graphic. I like my function to be arranged top to bottom for how they're displayed. So do the title first. Okay, so for this guy where you don't have any hovery mouse effects, so we have that. And then before I forget, because some scenes you don't want sprites doing mouse related stuff like clicking. So in order for mouse stuff to go, you have to set this enable mouse to return true, and that's how it knows that you want to do mouse stuff. I just realized that we're doing 4 tabs. Let's fix that real quick. Go into settings, editor, code style, JavaScript. Tabs 222. Apply, okay. Code, reformat code. There we go. Okay. So we got our title loaded. And then, so with the sprites, they actually have, let's flip back to this guy. New, fill it with white, and actually I'm going to duplicate this guy. That way I can just keep duplicating this blank one every time I want. Okay, so with the sprite, so normal graphics, you have You have your sprite, so any image. Sprite's really color represented by a rectangle called bounding box. So my character or whatever may be in here. But for our sprite, for positioning it, we position it up here in the corner. Computer graphics are based on top left is 0, so the very tippy top corner of my screen is 0, 0 for my monitor. So normally corner is always that, and we represent that as XY. For our sprites, though, in addition to an XY, they also have an origin. So the origin is another value that you can set. It defaults to 0, 0, so it defaults up here. But if I set it to like half of my image, that puts my origin here. So what that does is it means that x equals 0, y equals 0. It means the origin, wherever that may be, is going to be sitting on that point. Is going to be sitting on xy. So like if I put my origin here, at 0, 0, they would be that. So they become relative to that. So that affects both positioning and then also rotation. So if I was to rotate, it rotates around the origin, wherever that may be. So that's the difference between like, let's see, I think Photoshop supports origin, different origins. Maybe. Maybe not. Looks like I always have to rotate around. Oh wait, maybe it did just rotate around an alternate origin. Oh, it does. Cool. Doesn't visually show it, but if I'm alt-click, wherever I alt-click, that becomes the origin, so it rotates around it. So you can see, like, here, alt-clicked in the middle, I'm rotating around the middle. If I alt-click up here, I'm rotating up around that point. So even though I'm doing the same rotation on the same thing sitting in the same place, because the origin's different, it changes how it behaves. So our game engine basically does the same thing. So, but what I can do, the other helpful thing with that, beyond rotation, is I want to position my title. I want to position my title. So here's our screen. I want my title to be in the middle. So I can, so if we draw it here, so I could do, so if we judge this, so our root sprite is basically our screen for our purposes. So this would be root sprite.width. This would be, I'm just going to abbreviate R, roots.height, and then this is going to be a regular sprite, whatever. So in this case, we're talking about the title sprite, but whatever sprite it may be, width, s.height, and then we have an x and y, and then root sprite's origin is up here, but that doesn't really matter for these purposes. So to get something centered on here, one way I could do it is if I leave the origin up here, then to center it, it would be half the width of root sprite, so divide by 2, minus half the width. So that would, if you imagine our x, this value here would put us at this point halfway through, and then subtract, so that would be like, let's change color. That would be like, it would be like this, so the whole thing is there, and then we shove it back half of this thing's width, and that would put us where we want it to be. So minus sprite.width divided by 2. So that's one way we could do x, and then y is the same, just switch the width with height. Or what I can do as well, so this would be origin.x equals 0. Or if I was to go ahead and set the origin equal to half the sprite width, then that would mean X being right here. All of my X has to do then would be sprite width divided by 2. So it's really not that much difference, but it just looks a little cleaner. So that's what I'm going to do. I'm going to move my title's origin, and this is a point or a vector, so it's XY. And I can create the XY like this, or I do have a vector class, which we'll use here, which lets me create the new vector, or which is basically the same thing for most purposes. So we'll try to use this guy more often than just creating the XY. All right, and then I'm just going to set the X to half its width, this to half its height. Then I'm just going to set the width to be root.sprite.width divided by 2, and root_sprite.height divided by 2. And I'm going to destruct root sprite up here. So every scene creates its own root sprite. So I'm just going to grab the root sprite. So that'll position this image dead center. And then I want to do root_sprite.addChild title. But I'm going to actually put that down here. So all of the sprites have like a parent-child relationship. Let's see, that might show up. Well, we have an issue. But so duplicate. So when we render our sprites, what we're doing, and this is common of pretty much every game in 3D framework you'll ever see, as well as like the DOM in HTML and stuff too, is one sprite can have one or more children in it. So like if like this is the outer sprite, and then this sprite's a child of that, and this sprite's a child of that, and we attach them together and create basically a tree. So it's a lot like a family tree. So like this would be the root, and then it may have 2 children, and this one may have 2 children, and this one might have 3 children, and this one might have 1, and so on and so forth. We do this because it makes it a lot easier to move and attach things. So like our render function, all our render function does is I tell it render this one, and it walks the tree and renders each one of these for us as well. But then also, like say I had like a character that was one sprite, and then I put like a weapon in its hand that was another sprite, and then maybe even that weapon had an effect which was a third sprite. So each one of these would be children, and then if I move the character sprite, I could then the weapon and effect move relative to that without having to actually update anything about these, because they're part of the character. So when we add this title here, we're basically putting it as part of the root sprite, and then it'll all get rendered. No, go away. I don't know what that is. Stop it. I'm putting dots everywhere. Okay. Alright, so this should show up now. So let's take a look at what we have wired wrong. Okay, so network, probably just something building wrong. Okay, so it's looking for engine index.h index. So let's look at the server real quick. It should be looking for public engine. So why are we not getting, why are we looking, oh, did I not do a, no, yeah, okay, so that's gonna be annoying. So, problem is, because I have this nested in here, a layer, it thinks that it needs to move these up a layer, but then when I'm actually serving it out here, I don't have that extra layer there. So it's getting confused. So let's actually, yeah, let's go ahead and why don't we just simplify things here? I'd done this because I had originally thought to put multiple demos in one project, but I since decided against that. Although I'm doing it right now, but we're going to get rid of that. So I'm just going to change this to one public, and then instead of breaking this apart, I'm just going to take that off, make this public, and then ditch this. And then I need to make index.js, so we'll just tweak this guy for now and have it pull zombie shooter index.js. Okay, let's try that now. And demo, public demo. Oh, nope, we don't want the word public demo in there. Where'd the word demo come from? Oh, wait, maybe we do. Yeah, we do. So it should be public demo zombie shooter. Oh, this is just a case if I can't spell. Zombie. There we go. Zombine. Okay. So we're not blowing up, not showing anything because we need to go back here. So we made our scene. We have to actually add it to the engine. And so because this guy is async, when we set it, create the scene needs to be async too. You can't do async stuff at the top level. So what I like to do is at my top level create a anonymous self-initializing function. So anonymous because it doesn't have a name, and then self-initializing, this extra pair of parentheses here immediately calls this guy, because then I can mark this guy as async. So it's an async anonymous arrow, self-initializing arrow function. And now what I can do is we'll do await promise.all, because we're going to load multiple scenes just for typing reasons. And it's going to come in here and do, let's get scene manager out of engine. Scene manager dot add, and then we just give them a name, which can be anything, and then an instance of our scene. So this is our start scene. Gotta make sure we get it from the right place. Okay, so there's that, and then we do, so that'll add the scene to the scene manager, and then we'll just change to the start scene, and then we kick off the engine itself. Oh, and I'm missing something. This guy needs a wait, but then somewhere, I think it's here. Nope, not here. Hang on a sec, I need to check. Somewhere I need to pass in the root element, the actual HTML element that it connects to. Ah, right, I have to call engine.initialize. And this is where I give it that guy. Root. And that's just this is just the ID that I gave my div here. And so game engine will go through and build the canvas and stuff. And boom, zombie shooter. Alright, and I actually don't like this perfectly centered. I kind of want to move it up a little bit. So let's pop back to our start scene. And we're just going to knock it up. Let's try 50. So because, you know, we got our XY up here. So if I want it to go up, I subtract. If I want it to add or move down, I add. So I want to subtract, or so I want to go up, so I want to subtract. And boom, a little higher. That's pretty good for now. Okay. And then let's finish making our start button. So we made our start button there. We just need to position it. So just like the title, we're going to position it, or we're going to tweak the origin. Vector. Alright, so left, right, we want it perfectly centered. So we're going to do the same, just half its width. For the Y origin, though, I actually want to position it relative to the bottom of the screen. So I want it like aligned with the bottom except up. So I'm actually going to set its origin as 100% of the height, so the whole height. And then for the X, we'll just do that. And then for the Y, we're going to do this, and then we'll get 20 pixels from the bottom. Oops, and we have to add it. Oh, not divide by 2. Want it all the way at the bottom. There we go. Okay, and it should have moved when I moused over it. So I either have a bug in the engine, or I didn't name these right. So those look named right. So, and let's make sure I did this right. StaticKit enable mouse. Let's make sure that's what it's called. Oh, it's not static. Take the word static off there. So static affects the class itself, not the instance of the class. Not static affects the instance of the class. So if you think of classes as blueprints and then instances as the building, static affects the blueprint and not static affects the building. Okay, so there we go, and that worked. And so the other benefit of setting the origin to the bottom is that my shadow lines up right, because although actually our size is different. That's curious. Yeah, because I guess they have different heights, so you can see how it's kind of getting squished instead of just moving up. Um, hmm. Yeah, that's interesting. We'll mess with that later, adding something to the engine to allow different states to be different sprite heights. But for now, that's good enough. It at least moves and does something. So, that'll work. Okay, so cool. So there's that. So now, let's go ahead and we'll make a new scene for our game. So, the game itself. So this guy is going to have more than one file, so I'm going to make it a folder. We'll call it game. And then we'll make a new file in here called game scene. Okay, and then export default class game scene, extend scene, and Alt Enter on that to insert the scene. And then, okay, so I'm not going to do anything to it just yet, but it exists, so I can go ahead and I can add it here. So we'll call it game scene. Gotta import it. And then, so now let's go to our start scene. And I want, when we click our button, to go to the game scene. So what I need to do, I need to pass the engine into our start scene, because our engine has all the things. And actually, really the only thing I'm using is Scene Manager, so I could try to minimize things and only pass the Scene Manager in as well. So that's going to go to our constructor. So I need to create a constructor here, Scene Manager super. Okay, and then we're going to do this dot scene manager equals scene manager. But I actually want to make use of the new-ish private variables, because really in any other programming language I would do that private. So I'm going to make it private here. And why do I keep going 4 spaces? Hang on one sec. Format code. It's almost like it reverted on me. It wants me to do 4 spaces instead of 2. Weird. Anyway, so for the private ones, private members and variables start with a pound sign or a hashtag or a has another name. I can't think of it right now. But anyways, pound sign, and then the variable name, and you can declare it like this. And then we just use it like that. Okay, so we got our scene manager. So now, on our all of our sprites support. If we look at our sprite, they support 5 different event listeners. So on click, on hover, on mouse down, on mouse up, on exit. These only work if mouse enabled is true for the scene. Um, but so we can do onClick equals, and then we just give it a function. So this function is going to call this dot scene manager dot change to game. So now if I flip back here, we blow up badly. Wow, what did I mess up? Player. Those are all the old things. How did I somehow revert back to the old version? That's bizarre. Zombie. Oh, stupid thing. It imported the wrong version of the scene. It imported the. Ah. All right, that's enough. I gotta disable the buttons on the Wacom. It's going crazy on me. I keep hitting it with my hand. Oh no, everything's terrible. Express key properties. I'm stuck in this precision mode. I'm not quite sure how to get out. I clearly hit a button. There we go. Alright, let's disable these buttons. Sometimes I like them, but not when I'm flipping back and forth between the keyboard and not so fast. Alright, options. Disable all. Are you sure? Yes. Why not? Okay. Alright, there we go. Figure out how to turn them back on later. Okay. So, but yeah, as I was saying before my Wacom became possessed and tried to take over my computer, yeah, this is the big reason I want to have it actually separated out into its own repo, because IDEs get confused when you're importing things. Okay, so zombie shooter, hit start. Alright, so now we're on our game screen, which doesn't have anything yet. So let's go ahead, let's pop over to zombie.psd, find some clear, actually, let's shove all these guys over out of the way here. Yeah, as far as exporting them goes, they don't actually doesn't actually matter where they're positioned in the screen. They can actually even be overlapping one another, and it won't affect anything because it considers them on a case-by-case basis. Okay, back to 100%. Alright, so let's make new things. So let's refer back to our design plan. That one. So we have our some kind of lives indicator. I used hearts. We could do something else, but why don't we just do hearts for now? Our score is just going to be text, so we don't need to make anything for that. Although we could actually do a graphic for our score, for the text score itself. So why don't we do that? But then we'll have text for that. So that's, let's make a list here. So we have get a pen. Okay, so we have heart. Yeah, hit a button. Heart for the lives. Score word. Okay, so our character is just going to be an image, and it's just his weapon's going to be a fix. So let's make a player with a weapon. I guess we'll just call it a gun. It's probably just going to be a blob, but we'll do player. Alright, so we'll do our zombies. So zombie. We might add multiple types later, but for now we'll just start with one. And then we'll want a background image. So background. Alright, so 5 graphics to make real quick. So let's just make something quick and ugly real quick, and then we can always circle back and make them prettier later. Alright, so why don't we make the hair kind of brownish. So we're going to do this from like a completely top-down view. So And actually, why don't we start with kind of a skin tone? Get kind of a pinkish, whitish color. Sure. Okay. So, that's the head. And then, just to block it out, we'll do some shoulders too. Okay. So let's go ahead. First we'll do some clothing. So why not blue? Because I like blue. Do there. That's good. Alright. And I don't have to be too super duper precise with this right now. So I'm going to kind of bleed it into the hair zone because I'm going to cover that with hair. So there's our shoulders with our shirt. Okay. And now let's do some hair. So we're going to draw him or her with facing up, so they're facing this direction. So we're going to do the hair on the back half of the head. Kind of do whatever. Quick and ugly for now. And I think that would be a monumental forehead, so maybe we'll go a little further forward. Okay. And why don't we slap some ears on there? I'm going to use the eyedropper. I'm going to eyedrop that. And we'll just say one little ear sticking out there. It's probably too big, but oh well, they have really big ears. Okay, 2 ears. And then I'm not going to bother with eyes, but we will give them a quick little nose. Kinda. That's a big nose. There. Okay. And then we'll give them a weapon. So we'll just say and granted I probably actually let's do this. We'll draw the weapon on a layer underneath them. That way I don't have to redo things. So actually why don't we well we'll assume they're holding their gun with 2 hands. So why don't we actually give them kind of 2 hands. Actually, we'll do that on the layer underneath as well. I don't know what I hit. Yep, step. Okay. Brush? No, I'm not. There we go. Alright. 1 hand. 2 hands. There we go. There's our character. And I'm just going to hit Control A and smash all those layers down. Normally, if you were doing something nicer, you wouldn't just smash your layers together. You'd want to keep them separate. But, quick and dirty, I'm smashing layers. Okay, so there's our player. It's not too bad. Okay, and then, so our heart. So let's make a new layer. Let's lock this one so I can't mess it up. Let's lock all these guys too. Okay. So this is going to be our heart. And let's see, in the other game I did red heart, but this is a zombie game. Why don't we do a green heart? Because why not? Green heart. Okay. And give me my brush back. And actually, hang on. Kind of, for quick and dirty things, I kind of like this almost crayon look this charcoal brush gives. Fill it in, kind of purposely ugly. There we go. And that's clearly too big for our screen, so I'm gonna shrink it down a bit. That's probably about right. Okay, so there's that. Give me... What are you? I thought you were V. It is V. Why is that I switching? Weird. Okay, so there's a heart. Lock that. And then score text. So this will just be literally the word that says score. So why don't we stick with green? Make it a little smaller. Yeah, maybe a little bigger. Score. Dot. Dot. Okay. So that's that. Oops, score. Dot PNG. Okay. And we'll lock that. Or unlock for a sec. So I can move it. And then lock it back. Okay. So that's 3. What else do we have? We have our heart, score, alright, our zombie. Okay. So, zombie. Make a new layer. Alright, so zombie. Why don't we do green skin? Actually make it a little darker though. Maybe a little browner. There we go. That's a pretty good zombie, I think. Zombie. So there's a zombie head. And why don't we say it has its arms outstretched, zombie fashion? Because it's looking for brains. Okay. Okay, zombie. And let's say our zombie has a little bit of dark brown hair. Let's do a new layer. No. Change my brush. And I'm looking for something to. Let me go kind of wispy. And zombie's hair is kind of half falling out there. Something like that, maybe. Whoops. Why is that color? Oh. Wait, it's like. I don't know what this brush is doing. It's like it's erasing my zombie. Because it is erasing my zombie. Well, that's weird. Oh, it's a blend brush, that's why. Here, let's try this guy instead. That's terrible, but good enough. Except let's clean it up a little. It doesn't. Let's just go back. Wait, what's that one? Kind of looks like he has an afro. You know what? Let's leave it. We have afro zombies. And let's give him like some tattered brown shirt, which I really should have put under the hair, but too late for that now. Back to my charcoal pen that I like. Let's kind of squeeze the tattered remains of the shirt into there. There we go. Alright, it's beautiful. So there's our zombie. Okay. Oh, and actually, now that I think about this, so really, yeah, we might come back and rotate these guys in a second to align with our grid. I'm not sure if up or right ends up being 0 based on the rest of the code. Okay, 1, 2, 3, 4. Alright, and now a background. So, for our background, so in the other game I did a parallax background because we're moving, but in this one we're really more like we're trapped in a room and zombies are coming at us, or trapped somewhere. And actually a room doesn't actually make a whole lot of sense, so why don't we be trapped in a park? Because that way, because if we were in a room you have doors, so zombies couldn't come from just anywhere. So we'll be trapped in a park. And so our scene is set to 800 by 600. So I'm going to make a rectangle that size. That way it'll just fill in our whole thing. And then, so what I'm going to do here for this guy, I'm just going to use this as a reference for my size while we doodle on top of it on a new layer. So let's start with some green. Let's go. That looks good. Kind of dead grass. We're in the middle of a zombie apocalypse. No one's watering the yard. And I'm just going to kind of fill in stuff. It's okay if I go outside the edges because I'm going to come back and I'm going to chop it all off or mask it or something. So we're fit to that. Alright. Blah, 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 blah. Okay. And actually, let's duplicate our brown. And let's tweak the color of the brown a little bit. I want it a little lighter, and it'll be our dirt underneath the grass. Well, color is dirt. Maybe about that. A little light, but okay. And then let's go. Let's do another layer. And actually, why don't we go ahead and we'll create a group for this. Background.png and drag these ones into there. Nope. There we go. Okay, so this guy, I'm going to do a dark brown, darker than that, like that maybe, that. I'm going to just do kind of some smudges here. And then I'm going to go filter, blur, Gaussian blur. Gonna blur it up real good. There we go. There we go. So that kind of gives me a layer of patchy dirt. Then let's do another layer. Let's say there's like a... Come on. Do it. Nope. Alright. I'm going to say that there's like a sidewalk courtyard type deal in the middle of this guy. Maybe. And again, though, I'm just going to use that shape as a reference instead of trying to modify it directly. So we're going to go, we'll say it's like gray bricks, maybe? Yeah, let's go gray brick. Kind of a sandstone grayish color, maybe. Like that, maybe. And go back to my brush and a new layer. Alright, and then just fill it in, 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 fill it in. Okay. And let's do filter, noise, add noise, a lot of noise, monochromatic, Gaussian, too much noise because I want to keep my color. There we go. Filter, blur, Gaussian blur, too much blur. This time I just want to do a little bit of blurring, a little less. That's probably good. And I don't know if there's a filter that's going to do what I want or not, but let's try... Is it tiles that I'm thinking of? Maybe tiles. No. Filter, other... What am I thinking of? I thought there was a thing, mosaic. Is that what I'm thinking of? No, not really. I was thinking there is a thing that... my cats are attacking. A thing that would break it up for me, but I don't see anything like that. So let's just do some lines real quick, just to kind of give us like a brick-looking thing. So I'm just going to darken this guy. And kind of do... And then let's blur that. Blur, making terrible artist passable since Photoshop was invented. uh, Actually, instead of blur though, let's go and just drop the opacity a bit. There we go. Okay, and then want to load selection. Nope, that ain't what I wanted. Select selection. No. Wait, is that even the layer I want? No. That's the one. I want the circle. There we go. New. Yep. I don't use Photoshop enough lately to remember these things. It's like picking a random channel every time. That's not what I want. Can I do it this way? I don't think I can. Layer. No. So that thing I had trouble with last time and I figured it out, but then I don't remember what I did to fix it last time. Let's merge these two. And that. Nope. Wait, I need to change this to be all white. And then new layer mask, hide all. Nope. Layer, create clipping mask, no. Yeah, it'd be nice if I could remember these things. So I want basically this guy to be the mask of the other guy. But that's not what I want. Layer mask, hide all. And I want to copy this guy, paste it, go in there. Nope. Maybe if I rasterize this guy. You. Oop. No. Brush. Yeah, if I can draw on it, why can't I paste? Let me paste. Paste special, paste in place. No. want this shape in there. Okay, well, we might actually be able to do this now. Okay. Seriously, fill doesn't work in there now. Alright, yeah, I need to figure out how to use these mask stuff. I used to know how, haven't touched it in a while, so kind of forgot everything. Alright, that's good enough. Delete that, and then so we've got our little walkway there, and then I'm just going to kind of rough up the edges just a bit. Alright, there's our ugly little path thing, and then and nope, pinker. Go. Nope. I'm in the mask. New layer. Actually, let's make these dirt. So we have dirt going to kind of a little pagoda or a little patio thing or something. Dirt color. Let's go more brown and kind of a light dirt. A little more yellow. A little more brown. There. And I'll just give it multiple walkways. Walkways won't do anything in our game, but just for kind of the effect. And then we're going to drop the opacity a bit. So they're kind of blended in. There we go. Not too bad. Now we're going to do that thing that I couldn't do a second ago. We're going to... Can I add a clipping mask to a whole layer? Layer mask, hide all. Okay. So I'm going to rasterize this guy. I know there are better ways to do this, but this way will work for now. Pluck that guy out of the layer. Select all. Jiggle it a bit so my selection gets around it. And then fill this in for white. So if you've never messed with layers, basically it's a black and white image. White means it shows up, black means it doesn't, and gray means it kind of shows up transparently. And there we go. Look at that. Alright, so, and then we don't need this extra rectangle anymore. Okay, so that's our background. What did I do? Oh, we do still need that rectangle. I forgot it was our backing layer. Okay. So now I hit save, and we should have all those assets made. Oh, that's demo. Zombie. Alright, cool. So, now I'm going to scooch my Wacom tablet out of the way. Well, maybe I actually put away. I'll probably need it again in just a sec. Okay, so let's go to our game scene. Okay, so let's look over here. Let's close that guy. Okay, so why don't we start? We'll just toss in the background real quick. So that's just going to be an image. We're just going to plop it in there and not really have to do anything with it. So that's going to be something we put in initialize, because once we've done it once, we're done with it forever. So we'll say background equals new, and actually instead of new image sprite, we'll do wait. Image sprite.create from URL will be assets background.png. And then, so create handles sizing it for us, and because it's taking up the whole screen, origin 0, 0, and x 0, 0 is perfect, so literally all we have to do is add it. So we're going to grab our root sprite, and we're going to add it to the root sprite. And by the way, I could put these like right after I create things, but I always like to group my agiles together because the order actually matters. Everything's stack on top of one another, so just like if I'm painting, first thing is there, and then the second one's on top, and the third one's on top, fourth on top, fifth on top, blah blah blah. So the first thing I add is in the back. So by grouping them all together, it just makes it easier to control the organization. And some games you may have to swap them, and I haven't actually implemented that code yet because I haven't needed to swap them. This game I don't think we'll need to swap them either. So there we go. There's our background loaded. Okay. So now, let's go ahead, wire up, we'll do our player next. So let's actually make a new class for this guy, player.js. Export default class player. And these guys will use GameSprite because that's the one that has all that physics stuff wired up in them. And how I actually implemented GameSprite, as long as you set a static image URL, it'll handle loading stuff for you. So we do that, and then I just will come and I'll do it up here. We're going to do await promise.all. Just like our scenes, we're going to do player.load. And so with game assets, and really player is a special case because it really doesn't need to be this way, but for like enemies and stuff, we need to load our image once and then we can reuse it over and over again. Luckily, because we're in JavaScript land, web land, even if we call load on the same image 5,000 times, it'll still only actually load it once, which is nice. If you're using like Unity or something, you can't, well, I don't know how Unity handles it. If you're using other things though, loading it multiple times may actually load it multiple times, so you have to be careful about that. We don't have to be as much because our browser won't reload the same thing. But anyways, our code's written so it'll only load them once anyway. So we're gonna load the player here, and then we'll create a player down here. Create, and I'll stick the image we load. It'll stick this image in there and create an image sprite, because GameSprite is actually extending image sprite, so it's everything GameSprite has plus a little more. So we do that, and then so our player is going to rotate around probably the center of its body. So not necessarily the center of the image, but really like right here. So why don't we grab the ruler, or actually, easier. Let's open up the separated out player, and let's measure. Where'd they hide the ruler this time? I don't know if they are or not, but I feel like they move the ruler all the time. Okay, so like probably right there. So let's measure that from the top left corner. Okay, so if we look up in the top, we see width 60, H68, or the X2 actually. So we'll put our origin to that. So 60, 68. So player, and actually for these guys, we'll bake that right into here. So we'll do origin, new vector, 60, 68. Okay. Because every player would be created with the same origin, so we might as well declare that in the class. Okay, so got that. So now we'll do player.x, and we'll start the player out in the middle of the screen. But in this case, we actually would want loading the player up off-center in the middle of the screen would look kind of weird. So, well, let's not worry about it. We'll see what it looks like. We might change it later. So we'll just put it the x width divided by 2, player.y equals root sprite dot height divided by 2, and then we're gonna add a player. Okay. What did I forget? Let's see. Width of undefined. So that might mean that it didn't load the player image. And I don't actually see it over here. I should see the player image. So let's check. Did I typo? Assets, player. No, that should be right. Make sure it exists. Yep. Okay, what did I goof on? Alright, let's go look at GameSprite real quick. Should be load, image URL. That's what we set. Yep. And it's actually triggering. Let's look at our call stack here. So size to image, it's happening on create. So we didn't, wait, it said can't read width of undefined. So it can't read the width of the image. So yeah, it didn't load our image for some reason. That's curious. Extend GameSprite. So GameSprite should have the load. Image. Oh, wait. What did I? Whoops, I closed it. What did I call this guy? Image URL. No, that's right, isn't it? Here, let's do this. Undefined. Okay, so yeah, I am goofing up on something and I'm sure it's super obvious and I'm just not noticing it. Did I have a typo in the name? Static image URL? Nope. Should be static. Player extends GameSprite. Oh! Imported the wrong one again, I bet. Let's see. Or didn't import it anything at all. Engine render price. Oh! I somehow ended up importing Game Engine as the player instead of a regular player. That's weird. So blah blah blah. Oh. What? Hang on. Import player. Why do you want to import that as the player? I have a literal player class right here in a player file. Okay. It's just weird. IntelliJ's on drugs. From player. Okay. Start. Alright, cool. So there's our player. And actually, might be a little big. We'll leave him for now. We can always shrink him later. So one thing I want to do, it's going to get annoying if I refresh and I have to hit start, refresh, hit start, refresh, blah, 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 forever and ever. So what I'm going to do is I'm going to come here real quick. I'm going to short circuit this and we're going to jump straight to the game as soon as we load. And I'm just going to put a to-do in here to remind me to change it back to start when I'm done. To-dos are handy in a lot of IDEs like IntelliJ. There's a to-do window, and anytime any reference of the word to-do, it'll show up here. So you can tag it with to-do and then go through your to-do list. Very handy. A lot of IDEs do that. But of course I love JetBrains stuff, so they're the ones I'm most familiar with. Get rid of that console log. Okay. So now, we got our player rendering. Let's go, and we are going to let him move. So let's start off. We'll do, so we have three actions that can be done. We have moving left, right, up, down, rotation, and shooting. So we could, one classic setup for this would be to move with either the arrow keys or the WASD keys, and then have him point towards our mouse all the time. but since I'm still kind of excited about the gamepad stuff, I want to implement something gamepad friendly. So let's actually say that, let's say WASD or the left control stick will make us move, and then either the left and right arrow key or the left and right, yeah, left and right on the right analog stick of the controller will make us rotate left and right. And then we'll go with, let's see, WASD. Why don't we go with space to shoot on the keyboard and maybe right trigger to shoot on the gamepad. So let's start with the up, down, left, right movement. So what we're going to do, so how we generally do movement in games is every tick we're going to basically check what keys are pressed down, and if keys we're looking for are pressed down, we're going to take some action. So we're going to do that in our tick, and this is tick as in like tick-tock on a clock. And we get a parameter passed in since last, so this is the milliseconds since the last time we ran tick, so that way instead of just moving like some pixel amount every time, we can move amounts based on how much time has passed. And that usually works out much better because A, that's how physics works, kinda. And then B, like if you hit a lag spot or something, you'll still move like appropriately and it won't matter how fast you render or not. Because if we moved like say 50 pixels every tick, but your computer is like really old and you're running at like 5 frames per second, that means you're only moving 10 or 50 times 5, 250 pixels a second. But if you're running it at like 60 frames a second, then you're moving 3,000 pixels a second, so you're moving way too fast. So doing everything based on time works out much better, because then whether you're running at 10 frames a second or 60 frames a second, you're going to end up at the same, or 600 frames a second. Which, by the way, I have our game set to, there's a value in the game engine right now, it's just set to 60. So, okay, where was I? Game scene. Okay, so in each tick, so let's go ahead, we'll move this into its own function, so we'll just call it player move. Player move. Again, that little hash mark means that it's private, so only this game scene can call it. And we're going to pass down since last. Okay, so let's pop over to player, and let's give it a max velocity. So if you remember, I mentioned GameSprite basically has physics implemented here. So instead of like telling it to move X number of pixels, we give it either acceleration so it can speed up or velocity. And then we apply those forces, and then each tick it'll get applied. Oh, and we should set some friction or we'll never come to a stop. So let's say max velocity. So this velocity is how much we're moving right now. And we just really need one number for this. So we'll say 500 for now. And all of these values will be pixels a second. And then we'll say max acceleration. Will be 200 pixels a second. So acceleration is how fast you're speeding up. So basically, every second our acceleration gets added onto our velocity. So if we're at 0 velocity and 200 acceleration, a second later we'll be at 200 velocity and still 200 acceleration. And then if we're still at 200 acceleration, a second later we'll be at 400 velocity, and so on and so forth. So it'll add until we hit our max velocity. And then we'll set friction. So friction, how I've implemented it here, is basically kind of like negative acceleration, but it'll take you down to 0, so it won't just like constantly add on. So this is if you stop pressing a button, it'll start putting a friction on. So if we don't have any acceleration, Well, actually, friction always comes into play, but friction stops applying when you get 0, so it'll bring you to a stop. So, and this is again pixels a second. So let's actually do, kind of want a high number for this just because we kind of, like a really low friction would mean like when we stop moving, we'll keep sliding for a while. So like really low friction would be like we're on ice, and then really high friction is like we're moving normally. So you probably want really high friction. And in fact, these numbers may be off. So we'll start with them, and then we'll add from. We can play with them from there. So we'll set those up. And then what we're gonna do in our game scene is we'll check. Um, so the for the gamepad, we want the input manager, which belongs to the scene manager, which we'll get from engine, and we need to pass that in just like we did the other scene. So let's pass engine in real quick. Super this dot engine equals engine, and we'll declare engine up here. Okay, and we gotta go back here, and we'll just pass in engine. We'll just pass in the whole engine this time because we'll use different bits and bobs of it. Okay, so how the gamepad analog sticks come in by default. Let me turn on my gamepad. To get the gamepad detected, you have to hit a button while the game's open. And we can do get gamepads, and this will give us, and it's weird because it like I don't actually know what this list is and it doesn't show anything, but I know my gamepad's connected here. And you can use the gamepad connected and gamepad disconnected events to actually tell what's there, and that's actually what Input Manager really does. But for our axes, they come in and they're these numbers here. And you'll notice I'm not pressing anything, but these aren't 0. So gamepads never perfectly go, or analog controls never perfectly go back to 0 unless maybe you had some kind of super ultra crazy ultimate calibrated thing. I have an Xbox One wireless controller. These are what it's at right now. And if I and so they're basically in pairs. So this is the X, the left right of the left stick, up down of the left stick, left right of the right stick, up down of the right stick. So they're in pairs. And of course, or negative numbers means it's up, positive means it's down, or negative means it's left, positive means it's right. So like I'll hold down, so I'm holding down the left stick. I'll rerun that again, and we can take a look here, and we can see, so 1 is all the way up, and 0 would be all the way down, but again, it never goes perfectly back. So what we have is we have a dead zone. And basically anything inside the dead zone, we don't count it as being hit until we are a higher number than the dead zone, or a larger number, because negative and stuff. And yeah, so right now my dead zone, I have it set to 0.05. So any value below 0.05 won't trigger. So actually that guy would trigger it on that reading as being hit a tiny bit. So that's interesting. Let's redo that again. Yeah, so might need to make my dead zone a little bigger. And so this is basically like a percentage of how much it's hit being pressed. So 15% pressed, we don't count as pressed at all. Okay, so for my input manager, I'm just going to get gamepad axis. And so I have you pass in an index, but I do it in pairs. So 0 is the left stick's X and Y, and 1 is the right stick's X and Y. So look at the left stick's axis values, and then we're going to check. So again, our movement controls. So if the X of our axis is not 0, because our dead zone is going to chop off the stuff for us, so we can just check for 0 out here. So if we don't equal 0, or well, actually we have to do these as different bits. So if we don't equal 0, that means we're trying to move left or right. So what we're going to do is we're going to add to the player, and we need to actually set the player to a variable, to a member variable that we can access down here. So we're going to take the, and I try to code in a I've been trying to code this thing in a functional way, so instead of changing objects, I've been creating new ones to replace things. So we're going to say acceleration. So we're not going to modify the we're not going to modify the velocity directly. We're going to apply acceleration and then let the game use that acceleration to speed us up. That way we'll get like a start-stop movement rather than a like not moving and then suddenly moving. Okay, so if our x-axis doesn't equal 0, then our acceleration.x, we're going to make axis times this dot player dot max acceleration. So it is going to set it straight to its max acceleration. But since we have an analog stick, we have the benefit of we can be more precise with it. So we'll multiply it by axis. So that way, if you're hitting it, your control stick 50%, you're going to move less than if you're hitting it all the way. And by multiplying it, we're going to get the right direction. So if we're hitting it left, that means axis.x is going to be negative. So that's going to apply negative acceleration on the x-axis, which is going to move us left, and vice versa for right. So we're good there. So if we don't have that for the x, then what we're going to do is we're going to check our keyboard. So I'll do input manager dot is key down. Whoops, is key down. And I have a keys constant here. And what did we say? We said this is WASD, so A. Okay, so if we have the A key down, then we're going to do acceleration.x equals negative this dot player dot max acceleration. So A is left, so that's negative. Else, if we have, if we're doing D, then we're going to give it positive. Okay, so that handles our left right. So now we'll do pretty much exactly the same thing for our up and down. So basically all the y's change to, or all the x's change to y's, and that's actually what we have here. So okay, so this one, so up is W, acceleration.y equals minus this dot player dot max acceleration. You'll notice for the keyboard too, since it's not analog, we just kind of have to put it straight to maximum. So if you're playing with the keyboard, you kind of lose some of that that fine-grained control. Acceleration. Okay. Then I'm just gonna assign that new acceleration to player. Okay, so let's give this a try. If we didn't mess up everything, whoops, might be able to move left and right. Yeah. Should actually be. Yeah, should be working. Oh, we have to call this dot player dot move and pass in since last. That's the one that actually uses the values to do things. That's not the right spot. No, okay. So something went crazy. So let's just console log our player. See what our values ended up. Alright, so players X and Y is not a number. Huh, that's odd. Why would that be? Does sprite not initializing? Sprite shouldn't have rectangle. Rectangle should be initialized to 0. The sprite doesn't call its constructor directly. And that should be calling you. Huh. Curious. Okay. So let's go back to our games. Yeah, to our game scene. Oh wait, we set our player to some values. Where? Hang on a sec. The very first one. Okay, so the very first one actually does have value, which means it's getting transformed to not a number pretty much the first time we call move. So let's not call move for a second. Let's just look at what we've got our player at here. Okay, so so our acceleration ended up being not a number. That's why we ended up not a number there, because it tried to do math with not a number, and that causes everything to implode. So how did that end up not a number? So let's check that this guy has a value and this guy has a value. So console.log axis and this dot player, and actually dot max acceleration. Okay. What was that? Axis. Okay. Okay. So actually what I want, the problem was, so x doesn't exist, so x is undefined. Undefined doesn't equal 0, so it was doing this, even though I hadn't hit anything. So really, though, we just want to do x-axis and y-axis, because it'll only trigger those if it's a number that isn't 0. So undefined won't trigger it, and 0 won't trigger it. So that worked better. There we go. Now, okay, so now we're generating some acceleration. Wait, what is that? That's our axis, actually. It's our acceleration. No, our acceleration is still foobar. Alright. So put acceleration here again. Oh, you know what? Let's double check that we're compiling. Expected token. I think that was a while ago. Yeah. Okay. Alright, so 0, 0, so that's valid. Alright, I'm holding the left stick down and we're getting non-number. That's not good. Hitting the hitting A, I am getting a number. Okay, so our control stick isn't working, but our keyboard is. Interesting. Okay, so why? Alright, so, and we are outputting. Oh, derp. I was trying to multiply the whole object. Axis.x, axis.y. There we go. Alright, now we're not turning on number. Alright, so now let's try turning on move and see what happens. Get rid of those console logs. Okay, and we're not moving. Alright, so let's put those console logs back in. Actually, we can get rid of that one. Just do the acceleration. Okay, so acceleration should be a value. And let's output this dot player. Okay, so our player's x and y is actually changing. Just changing really tiny. Oh, and look, we are moving. We're just moving infinitesimally slow. Why is that? Huh. That's cute. Oh, that's why. So our friction always subtracts from our velocity at the same time acceleration is happening. So we're actually putting 200 acceleration and then it's being almost completely wiped away with friction. That teensy tiny bit we were moving was a rounding error. So we actually want to crank up our acceleration to be basically the acceleration we actually want plus friction. So we're going to go 500 because we kind of want 200. Alright, let's try now. There we go, yay. And you'll notice since I'm using physics, so I let go, and we slide a little bit. Let go, slide, let go, slide. Um, so for like my spaceship game, that's probably pretty good because you can't stop a spaceship on a dime. For a human walking around on the grass, though, I would expect a human to be able to stop a little quicker than that. So why don't we crank up, or we'll crank up the friction a little bit. There we go. So now I let go and we stop almost immediately. But that's a little slow, so we'll crank up the acceleration a bit more. There we go. That's pretty good. And I think we can make ourselves a little bit faster, so why don't we go 800? There we go. That feels pretty good. So let go. Whoop, now we're sliding too much. So we gotta add more friction, and then we gotta add acceleration to compensate. There we go. Alright, cool. So that seems pretty good. Okay. Of course, we can always play with them more later, once we actually have all the parts done and we start play testing and tweaking things. Okay, so now we got that going. So now let's add rotation. So we'll get rid of these console logs. Alright, so for the rotation, we're just going to add to the rotation. And actually, it just dawned on me that I have just rotation here as a value, but really rotation should always clip itself off, because if you think about it, if you go 360, you've made a full circle. So really 360 and 0 are the same number. If you do 3 loops, that's, 1080, but that's still 0 degrees because we're rotating around. So we're going to chop off the extra bit, so we'll always be basically between 0 and 360, except where we use radians here, so we're really going to be between 0 and 2 pi. So I'm going to use a setter here. So basically, outside of here, it's going to look like this, just a regular variable, but then inside here, if we change it, it's going to actually update this. So rotation equals value mod math 2 times math.pi. So modding is a handy way. Modding gives you the remainder from division. So like if I do 5 divided by 2, the whole number part of that is 2, and the remainder would be 1. If you do like your elementary, middle school long division, 7 divided by 5, remainder of 2. So mod gives you that remainder. So if I want to cap something between 0 and some other number, I can just mod that value. So like say I want to, as I add, I want to keep the number capped to 100. So if I do like 110, that's mod 100, my max, then it'll keep me linked in between that. And then, as I go up and up and up, eventually I'd get to 99, 100, back down to 0. So we're doing the same, but we're doing it with 2 pi, because we want between 0 and 2 pi. Alright, so we got that. So now let's pop back. And really, we don't have to cap it like this, but if you think about it, if I sat there and kept spinning in a circle for a very, 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 very long time, eventually I would hit the maximum number I could store in JavaScript, and then it would loop over to negative number, and that would create all kinds of weird issues. So better to cap your numbers off. Okay. So let's go here. So just like the other one, we're going to check for things. So let's actually change this to be, we'll do refactor rename, we'll do left axis, and notice it changed all those for me because WebStorm's great. axis equals input manager dot get gamepad axis 1. So that'll be the right stick. So if right axis, so this one we're only going to do left and right. So if we have an X, we're going to do this dot, and since this is just a single value, this is a scalar, we'll just add it directly here. We're going to add rotation. So let's go real quick to our player, and we'll give it a rotation speed. And let's say, maybe it takes 1 second to do a full rotation. So we'll say 2 pi radians a second. So it'll take 1 second to do a full loop, and that may be too slow, so we may revisit it, but that's a good starting point. So what we'll do is we'll add to the rotation an amount that is right axis dot x times this dot player dot rotation speed, and then times since last divided by 1,000. And actually we'll do 0 because it might be, since last might be undefined. It shouldn't be, but it might be. So because we want to do rotation per second, but we don't actually want to wait a whole second to rotate, because then it'd be like, a clock with like a second hand, do nothing tick, do nothing tick. We don't want that. That makes a terrible game. So our since last is how much time has passed in that second. So if we divide that, how many milliseconds have passed. So if we divide that by 1, we get a percentage of a second for how much has passed. So we multiply that by the rotation speed. So if you do that for a second worth of ticks, you get the value equal to our rotation speed. And then because we're analog, we're going to multiply that by the right axis, so that way holding it more or less will make you move more slower or faster. Okay, and then we're going to do arrow left, and this is going to make us, and we'll do subtract from, and then we'll basically, it's this bit. And actually, because I'm about to repeat this 3 times, let's just do this. Rotation amount equals that, because that's going to be the same for all 3. And then this guy will be plus the axis times that, because again, if it's left, it'll be negative, so that'll take care of it. Alright, rotating left, we're going to do negative, and actually, this may actually be different. This may actually be positive, I think, how I have it coded. We may actually need to flip that around. But let's try this for now. Rotation amount, and then else if input manager is key down keys dot arrow right, this dot player dot rotation minus equals rotation amount. Okay, so now we should rotate. So let's see if that works. So, hey, look at that. It works. So left makes me rotate that way, right makes me rotate that way. I think that's probably a pretty good speed. So if I move around, woo. Yeah, so, this is actually kind of tricky because I'm moving left and right. What might make more sense would be for it to face the direction that my stick is going. So like if my stick is in the lower left, I face lower left instead of spinning like I am right now. So why don't we tweak this a bit? So time for some math. Alright, so let's figure this out. I'm not sure this one off the top of my head. So delete that one. Clone that one. Okay. So grab my Wacom tablet. Alright. So alright, so with our control stick, we have 2 values, X and Y. And so if we think about our control stick, so this is our analog stick. If we were to go, say, like our bottom left corner, that would mean our X would be, not sure if it would be 1 or 75. We'll say it's, well, here, why don't we find out? Alright, so I'm going to hold the left control stick in as bottom left corner as I can. And we got, okay, yeah, so it's about 75-80% because you're on a circle, so you're not quite getting 1, but okay. So we got x equals, we'll say negative 0.8, y equals, and that's down, so 0.8. Okay, if we were this way, we would have x equals 0, or x equals negative 1, y equals 0. And if we were all the way up, we would be x equals 0, y equals negative 1. And what if we were down this way? We would be x equals 0.8, y equals 8.8. Yeah, both positive. Okay. I like to do that to give us some data points. So, and then if we translated these into rotation angles, we would say that up would be, so, well, actually, for our guy, 0 is up. So this would be 0. And this direction, 2 degree equals 0. This direction would be quarter pi, because in radians, 1 pi is, or sorry, half pi. 1 pi is 180 degrees, so 90 degrees is half pi. So that would be half pi rotation because we're going this direction, I think. That might be flipped around based on how I did it. I think I did it clockwise, but okay. So and then this direction, that would be what? 3 or yeah, can't do math. That would be half pi plus 4 pi, which would be, there we go, 3/4 pi. Okay, and this would be 1 pi plus a 4th pi, 5/4 pi. And, okay, so that's all our data points. Okay, so I think what we're probably going to have to do, let's see, so let's pick this one to start with. So if we think about it as a triangle, from our origin. So this angle right here is the angle we want. And we would be, yeah, so absolute values, it would be 1, but we'd be 0 here. Now, yeah, really we want to think of it more as we're the ones we're making. We have this line, or we have this line, then we're making a right angle to the origin. So if we were to do yay, trig. I get to remember trig. Yeah. I haven't done trig in a while. I haven't been doing Okay, so let's see. Yeah, if we say that it's alright, let me think about this, sorry. If we have a line like this, which is defined as point from 0, 0 to some arbitrary point, and this point is xy. And we may have to rotate this, but let's think of it in normal Cartesian coordinates for a second. So we have some point y. We basically want to know the angle that's created, the angle between here. So if we do what? Let's see. What is that? Tangent? Tan theta equals SOHCAHTOA, opposite over adjacent. So our opposite is basically our y, and then our adjacent is x. So equals the a tan and the negative 1 tan. What's the negative 1 tan? Xy. So that would give us through there. And if our angle was, say, here, our angle would be that. Does it still work? Not really, because we would have then this y and this x. And no, actually, maybe that will still work. But we might have to add to it. Okay, so let's start there, and let's see what kind of numbers that starts spitting out. We'll probably have to rotate it at least 90 degrees to get it aligned with our guy, because our guy's not aligned with Cartesian coordinates. And he might actually be rotating backwards from Cartesian coordinates too. So, we'll block all that out. Okay. So, let's see. What is math dot actually, you say 10 too. And this also doesn't work if x is 0, although I think a10(2) may actually have a thing to deal with that. Let's find out. Because you're doing, x0, blah, blah, blah. But I think a10(2) takes that into consideration. So let's do right axis dot y, right axis dot x, and let's just console log that. Okay, not a number because I'm not pressing anything. Okay, so going to go to the right, we get 0, which is actually what we wanted, linked with Cartesian coordinates, because that would be 0. If I go up, we get 1. We get 1.5, blah, blah, blah. So that right there is half pi, negative half pi, which would be rotating. That might actually be right for us. And then that's 1 pi. And then that's half pi. Half pi. Okay, so that might actually be good. So we do need to rotate it by half pi because our guy's off half pi. And actually, I think it might be negative because I think he is backwards. But okay, so let's actually do if right axis dot x or right axis dot y. Okay, so if we're doing either of those, we're going to come in here, we'll do this dot player dot rotation equals rad. And actually, we don't need that extra variable, so just this player dot rotation. Okay, so let's see what that causes. Okay, so I hit left. Oh, actually, that works. He's following where I'm going. So I'm pressing up right now, pressing left, pressing down, right. Nice. First try. Alright, cool. So yeah, so now he does kind of jump around, which might not necessarily be desirable, but I think for now, to keep it simple, we'll just go with that. What we might implement in the future is like if I'm facing left and then I hit right, instead of having him immediately jump right, he'll rotate towards where I am. But for now, we'll just keep it simple, so we'll do that. Okay, so we got that. So now let's also, so if we're going to do that for the controller, how about instead of the arrow key setup where left rotates to left and right rotates to right, we'll switch and we'll do the mouse. So our character will always point towards the mouse. So else if, well, just else, or actually not just else. So, what do I call that? Is mouse over. That one. So I have it so if our mouse leaves the canvas, Input Manager stops tracking it if it leaves the game area. So we'll check to make sure we're tracking it. And then as long as we're tracking it, we're going to point the player at it. And then this math is very similar to the controller math. So basically we have like, if you imagine our Cartesian coordinates there, mouse is here. We know it's x and it's y, which gives us our triangle. And then it's tangent again. Might need to, again, shift it a little bit, but why don't we just start by plopping in the most obvious values, and we'll see if we need to flip it around, and we definitely are going to need to rotate 90 degrees again because 0 still faces that way. Okay. Alright, so this guy is a little confused. Oh, right, so the X and Y I just plopped in there is actually based on this corner. But we actually want it to be relative to our player because our player is basically the middle of our graph. So let's do minus this dot player dot y and minus this dot player dot x. And because we have the origin in there, it's going to be relative to here instead of like the top left of the image, which works well. Hey, look at that. We have it facing the right way. Cool. So now we have roughly equivalent controls. Oops, gonna get over here. For either keyboard or gamepad. And if you were crazy, you could technically use your gamepad for one thing and then mouse for another, keyboard for another. But that would be weird. Don't do that. Okay, so cool. So we got some rotation. I'm just going to put some new lines here to make that a little more readable. Cool. So we got player movement. Yay, that wasn't too bad. Okay, so now let's go ahead and let's implement the ability to shoot. Oh, shooting requires a bullet. We didn't make a bullet. Let's make a bullet. Alright, so, oops, and let's lock that guy. Alright, lock that guy. And bullet. Okay, so let me grab my tablet for the super complicated making the bullet. Let's go. Do we want to go realistic and make it like a gray or a yellowy color? Yeah, why not? Alright, ready? Here's the bullet. Super complicated. Doom. Yeah, that's actually terrible. Alright, more complicated than I was sarcastically implying. There, bullet, done. That was hard. Okay, so again, I have our bullet facing up as well. Since our player is facing up, because when we fire our bullet, if we're firing this way, we want our bullet to face that way. If we're firing this way, we want our bullet to face that way. So I've oriented it the same as our players, so then we could just copy our player's rotation, and it'll be the same for our bullet. And we'll just have to make sure that we put our bullet's origin in the middle of the image. Okay, so hit save, and now let's go, just like our player, let's make a new class for this, because that ends up being easier. Bullet.jpg or .js JavaScript. Export default class bullet extends GameSprite. Okay. And then we just need to set our image URL assets bullet, and it imported the wrong thing again because oh no, that is the right thing. Never mind. Okay, and we'll set our origin to a new vector. And actually, so we actually we can do it here. So GameSprite uses that game URL and it populates a static image. And so we want this to be bullet.image.width divided by 2, bullet.image.height divided by 2. And actually, I set, yeah. And we could get away with this because we're going to call load before we create an instance of bullet, which means that that image will already have been loaded. If this wasn't static, we wouldn't be able to write it like this, but we'll be okay with because it is static. Then we'll come down here, bullet.load, so we'll load the image. It's not creating a bullet yet, it's just getting the image ready for us. And you usually do that in all kind of game engines. You have to load your assets before you need them, because trying to do a just-in-time loading is always going to mean that they're not going to be loaded when you need them, and they're going to pop in and be ugly and stuff. Okay, and then we're not going to create a bullet in our initialize because we're only going to create a bullet when we shoot, but we will create a place to store our bullets. And then let's pop into player. So we don't want player to be able to just fire, infinity bullets, because that would be annoying. So really, if we didn't cap it, you'd be able to fire one per tick. So we're at one per tick, which is one per frame per second thing you get. So 60 frames per second, you can fire 60 bullets a second. That's probably a lot. You would be able to fill the screen with bullets forever and never run the risk of anything ever getting close to you if we kill them with one shot. So let's limit our rate of fire. So we'll give ourselves a fire rate. And we'll do this in terms of bullets a second that we can fire. So let's start with 5 bullets a second. Okay. And then a couple ways we can keep track of this. I like to let the thing that it involves keep track of it. So we're going to let player keep track of them. So we're going to do have a fire and a private can fire. And then so fire, we're going to expect since last, and then we're going to check, can we fire? And if we can fire, since last, if we can fire, then we need to keep track of when we last fired. So let's make a new variable for that, last fired. It's not set to anything right now. This dot last fired equals since last, so we'll know we did that. And then we can either do automatic fire, so that's just like you hold down the fire button and it shoots as fast as possible, think like AK-47 style, or we can make it so you have to pull the trigger for each individual bullet, like a pistol. So we can do either. The only real difference between the two, if you want pistol fire, you keep track of if you've pushed the button down, and then you have to keep track when you let go to make sure that there's a push, release, push, release, push, release. I did that on the space shooter. So for this one, let's just go auto fire. That way we have two different examples of two different ways to do it. So in this case, we don't even have to keep track of that. We're just going to keep track of when we last fired, and we're going to return true. And then we're going to return false. Because this guy's not actually going to create the bullet. It's just going to say, hey, yeah, you can make a bullet. And then can fire is just going to be if this dot last fired, let's see, since last minus this last fired. So since last it, sorry, let's see. No, sorry. That would be for real time. If we had now, we could subtract them and we could keep track of them that way. But I don't want to pass now, and I just want to pass since. So we'll do since last fired, and then what we'll do. Hang on, let me think about this. Actually, you know what? This may have been a slight bug in how I did the last one, because yeah. So this guy was actually getting a limited fire rate because it would keep track of since last fired every time you call fire, but it'll only call fire if you're hitting space. So like if you don't hit space for a while and then you hit space, you may not fire still because you have to like hit space enough to trigger it. So yeah, that actually, I should probably fix that. Alright, so for this guy, I think we do have to actually get now instead. So difference between now and since last is now is just the time, and since last is how long it's been since our last tick. So we could actually get now ourselves by just date.now, but I don't like to do that because if you generate now multiple places, now may be off by a little bit because time passes in between those. So what I like to do instead is have one kind of source of truth for what now means, and then it passes it in. So scene manager is where I'm getting my now. So what I'm going to do is so this is the scene tick function. So this is where the since last is coming in. I'm going to pass in now too. So now I have, and I don't actually have to put it here, but I'm going to put it here just so we know that it exists. So now, and then that means here in my tick, I now get past the now, and then I'll be able to pass now in in a second when we do that. But so we'll have now available, and so then we'll use now. So now we can do that math I was originally doing. So now minus last fired. So this is how many seconds have passed since we last shot, and as long as that amount is greater than or equal to our fire rate 1000 divided by fire rate. That's not fire rate. So yeah, so if our fire rate is 5 bullets a second, that's basically the same as a bullet every 200 milliseconds. So as long as the amount of time between now and when we last fired is greater than or equal to 200 milliseconds, we are allowed to shoot. Okay, and really this one's simpler than the other, so I'm going to get rid of can fire, and I'm just going to plop this up here. I don't think we need that whole separate function for one boolean. Okay, so we got our fire. So now what we're going to do in our game scene, so let's make a new function, player fire now. We're going to use now. Whoop, we got, oh, that's just yelling at me because I haven't made that. Player fire. Now. Alright, so if this dot player dot fire, first we want to check, are we hitting the button to fire? So let's destruct out our input manager. And By the way, the reason I destruct like this is because if I didn't, every time I used Input Manager, I would have to type this.engine.sceneManager.inputManager over and over. I don't want to do that. So I always destructure out my variables usually. So, Input Manager. So we have is gamepad button down, and then it takes an index, but I have a gamepad buttons set of enums here. So we said right trigger, which is R2, or input manager dot is key down, and there's a constant for those two, space. So if we're hitting R2 or we're hitting space, we're going to fire. Maybe. So if this dot player dot fire now, so we're holding something down and we can fire, and actually we don't have a release step on this guy, so we can just combine these all in one. Let's do parentheses to make sure they group up right. Okay, there we go. Okay. Okay. No, sorry, changed my mind. Don't really like that either. Okay. There. Alright, so if we're hitting one of the buttons and we're allowed to fire, then we're going to create a bullet. Equals bullet.create. So we make a bullet. We're going to start the bullet out. So we could put it right in the gun, but I'm lazy, so let's just start out at origin, just because you won't really notice the difference, and it's going to be a whole lot easier to start it out there at the player's X than it is to try to calculate that a little bit. And no one's going to notice because the bullet's going to be moving fast enough that it won't matter. Okay. Put it up, but this is a case where we're going to have to rearrange our elements, so we're going to have to go implement that in our library. Okay, so we set the bullet up, and then for these guys, they're still going to use the physics stuff, but instead of giving them acceleration, we're just going to start the bullet off at a velocity, and it's going to keep going at that velocity, and it's going to have zero friction, so it's going to just keep going forever. So bullet.velocity equals, and then let's set a rotation equal to the player rotation. And then, so our velocity now needs to be some function of the rotation. So real quick, let's come here, and we'll do a max velocity of 500. So when we do rotation with a max velocity, we want to make sure that it's adding up, because we can't be like the way you might be tempted to do it is like if you have y equals 0.8 and x equals 0.8, and you might be like, oh well, that times 500 and this times 500. Problem is though, this equals much more than 500, so that would mean that bullets flew faster diagonally than they did like straight up and down, where like x would be 1 and y would be 0, or vice versa. So what we have to do, a little more trig here, it will be what is it? One of them, it's yeah, one of them's cosine, one of them's sine, and I always forget which is which. Sine, blah, blah, blah. So I want to say, so it'd be max velocity. Max velocity. I want to say sine is y, and cosine's x, but I'm not sure. But we'll check them out. And we can get away with this because cosine of an angle plus sine of an angle always equals 1. So if we multiply that by our max velocity, that's always going to equal 500. So we're going to be just as fast shooting one of perpendicular direction as we will be at an angle. So let's go here. Oh, and actually we'll do a new vector instead of that. Let's see. So bullet dot max velocity times, and I think it's cosine or sine. No, maybe I might have these backwards. I always get them backwards. We'll do bullet dot rotation. They're the same thing now. And then this is the same thing, just times sine. And sine and cosine will be negative and positive as appropriate, so they'll take care of making sure they fly in the right direction. Okay, so we got that. Then we'll add it to that bullets array that we did. And like I mentioned, I try to do functional programming, which means I don't like changing things. In a game engine, that might come back and bite me, and I might have to tweak it. But for now, I'm going to go functional. So instead of doing push and adding it to the array, we're going to create a new array. And then we're going to do... we're going to add it to the root sprite as well, so it can show up bullet. And then going to go ahead and we're going to implement bullets move since last. And this guy is actually really straightforward. Bullets move. And we're just going to loop through each of the bullets and just call bullet.move, pass in since last. And the game engine physics stuff will take care of it. And oh, I forgot to initialize this initially. Okay, so fire. Oh, no, not fire. We're not firing. Do I have bullets underneath me? No. Okay. So, what did I miss? So, let's come in here. We'll do fire. So it could be an issue with this guy's never returning true, so we're not doing this. Or it could be an issue with we're doing this, but something's wrong in this. So what we're going to do is we're going to, if we put this fire here, which is kind of in the middle of our problems, if we see this, the problem's down here. If we don't see it, the problem's up here, which means really probably in there. Alright, so fire, fire, fire. Not doing anything. Okay, so looks like the problem might be in player. So let's pop over here. Okay, so probably our issues with our math here. So let's just do console.log. And I'm going to change this sign to a comma. And so we'll see what the two values are. So then we can just visually look at them ourselves. Okay, not a number. Okay, so last fired right here is nothing the first time. So that's now minus undefined is not a number. So we'll initialize that to 0, and then we should be good there. Okay, so we fired, and then we blew up here. So we blew up on size to image. And this is probably that same issue we had a second ago that I totally forgot what we did. It probably pulled in the wrong file again. And then it did. It went. Why are you doing that? I want the bullet to be that game sprite class 2. It is a game sprite, but it's not that game sprite. Am I doing something weird there? Export default class? No? Yeah, that's weird. Okay, got an issue. Alright, bullet not found. Looks like I forgot .png on it. Yep, .png. Okay, and fire, fire, fire. Not quite what I meant. Well, it is actually rotating them. Firing them. We're just off 90 degrees. Which actually makes sense because we need to be going perpendicular to... No. Yes. No. Baby. The rotation is actually right, so facing this way, the bullet's rotated right. Just the way it's moving. That means I probably got sine and cosine mixed up. But actually, now that I think about it, in my defense, it probably is normally this way, but because our player is oriented 90 degrees from real origin, math is backwards. And now we're firing the wrong direction. So our x is actually right. Our y is needs to be negative. Okay. Actually, that seems familiar. There we go. Alright, so now we're shooting our bullets. Our very large bullets. Let's shrink our bullets down. Doo-ba-doo-ba-doo. So, bullet, transform, shrinky, shrinky. And hold alt. There we go. And there we go. It might be too small, but just a little speck. Okay. So, because everything's dynamically sized. Okay, cool. So now we're good there. And you know what? I kind of lied because I kind of do notice that we're not coming out of the tip of a gun. Obviously the bullet's on top and we're going to have to swap the sprite level, but like when I'm rotating fast, you can tell that the bullet didn't just come out of the tip of the gun, it came out of like the edge of the gun. So let's go ahead and we're going to shift it an amount. So really we should just be able to do this sine cosine stuff and move it that way too. So let's see. So the x is going to be well, so let's think in terms of zero rotation first. So in terms of zero rotation, we're not going to move our x at all. We're just going to move our y. And let's say we're going to move it negative. How far is that? Maybe 100 pixels? See what that looks like. So firing it from up, that's kind of too far. Let's go 50 maybe. And we could get out the ruler, but why not just randomly guess? Okay, not quite. No, that's in the gun. That's actually pretty close, so let's nudge it maybe just 5 more. Okay, so that's pretty good. So that's like exiting out of the barrel. Okay, so now we know we want to move negative 55, so now we're going to multiply them by our numbers. So times negative math.cosine, and negative might not be right in this case, but let's try it. And then minus 55 times math.sine bullet.rotation. Okay, so alright, so they're shooting out behind the back of his head now. Not quite what we want, so let's get rid of that negative and probably add a negative to that guy to make him work right. Okay. Yeah, we look pretty good. Yeah, now it feels like it's coming out of the barrel of the gun instead of flying out from the middle of him. And now let's simplify our signs. So negative and negative, we make that a positive and that, and then positive and negative. Alright, so now we're good. So now we need to fix the issue where it's coming where the bullet's on top. So if you remember, I mentioned that we draw things in the order they're added normally. So the bullet was added after the player, so the bullet is on top of the player. So we need to go add a thing to sprite to be able to insert things in between things. So in addition to add child, I'm going to add an insert before. So child will be the child you are wanting to add, and before is what you're putting it before. So, and then we're going to need to find the index of the before in children. And then we're going to, and if, just as a safety check, child does not, and we'll make that friendlier later, but if index was -1, that means it's not there, it's not a child of it. So okay, and then in a non-functional way you would do a splice, so we're going to do basically a functional splice. So to do that, we're going to do this.children.slice 0 index, so we get everything before the index. Or actually, this will include the index, so we actually want to do -1 in this case because we want before that index. Then we're going to stick in our child here, and then we're going to do the index and everything after. Okay, so now we got that, and then if we come back to game scene, so instead of add child, we'll do insert before this dot player. Okay. I made our background blow up. But hey, our bullets are underneath, so that's something. Alright, let's go back here. I think I was wrong about... I'm always off by 1 when it comes to those. Where are we, sprite? So, let's see. It's actually... Is it still that? Yeah, I guess it is still before that one. Yeah. Hey, he's gone now. How'd that happen? Wait, what? Okay, over here. So, 1, 2, 3. So, we want to insert something before 2. 2 has an index of 1. So, actually, here, let's do that. Alright, so, index of 2. So, its index is 1. So, a.slice 0, 1, that's that index. And then we'll insert 4, a.slice, and then 1 again, because the index. Okay, yeah, so that's right. So why did our player disappear? Slice 0 index, and then slice index plus 1. Interesting. How are we losing that guy? Stud children does slice 0 index. Oh, right. Sorry. We plus 1 when... No. Yes. Yeah, that's it. We plus 1 when we want to remove things, which is what I'm normally use this for. But we're not removing anything, we're just inserting something before. So, no plus 1. Okay. There we go. We're firing. And that's with the spacebar. And let's just make sure our right trigger is working as well. Oh, my controller is asleep. Alright. Cool. Nice. Alright. So we can move around. We can shoot bullets. Bullets are kind of hard to see, but... Yeah, why don't we make the bullets white? Okay, so bullet, and I'm gonna use hue saturation changing. And colorize. Okay, we're gonna go. We'll stick with a yellowy color, but let's go with a brighter whitish color. There we go. Let's try that. There we go. Oh, much easier to see. Okay, cool. And now let's clean up those console logs real quick. Alright. No, that's not the only one. Player had one too. There it is. Okay. Fire, 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 fire. Alright, cool. So now we got our player. We got our bullets. Let's go ahead. Let's throw on... Oh, and we're not using rotation speed anymore, so we can clean that up. Okay, so let's real quick go ahead and throw on our lives. And I'm actually going to just yank this guy from Space Shooter because it's pretty much the same. Basically, the live sprite implements regular sprite, and then it has one or more live sprites, which are individual hearts. And it'll just have however many hearts showing based on however much life we have. So I'm just going to copy and paste this guy. And double check that the imports line up right. Seriously, you're flagging me. Oh, no, it's flagging the whole file. Okay. Don't care. Leave me alone. Don't need that guy. And okay, so that should be good. What did we call that? I think I called it heart. Yeah, so we'll switch this guy to heart. Leave me alone. I don't care. Disable. Okay, so it should be good there. Okay. Now we go game. So just like all the others, we'll do lives.load. You'll probably try to import the wrong thing again. Well, at least it didn't try to import the game object. Okay. And then, so this guy will need to be able to update. So we'll put it down there. And then we'll create one and initialize. And we'll only ever need to create the one because we could just keep reusing it. Okay, I'm going to start at 0 because we'll actually let player keep track of its own lives. And we'll say, and actually what I want to do, let's do it real quick, is have a reset method, because instead of creating a new player, if we play again, we'll just reset this one. So this will come and set all of the values that might change back to their default. So fire rate is 1. And let's add a constructor real quick. And anytime we construct it, we'll call reset 2. And then we'll just have them live down there. We'll change we'll put max acceleration and velocity down here. Put these down here because if we decide we want to implement like power-ups or something, we might change these numbers. What? Did I get those backwards? Were those both 800? Yeah. Okay. We might decide we want to implement power-ups or something, and that would change that might change those values. So let's reset them just in case that's the case. Okay. Friction we don't have to declare because it's already declared in GameSprite. We declare these two. And strictly speaking, you don't have to declare them, but I like to declare them because I think it makes your code easier to understand in the future. Then origin will never change. Okay, so we got that. And then let's add lives to this guy. So we'll start out with 5 lives. Okay, and so that's just the numeric count of lives. It's not going to display anything. But then what we'll do is we'll do player.lives here. So that'll feed in the number from it. And then, so positioning. So its origin is the top left. That's good because we're just going to position it like 10 from the edges. And then we'll do this dot lives equals lives to make sure we can access it later. And then order for these guys doesn't really matter, but well, I guess it kind of does because we want our player to be behind our lives, so we'll make sure lives is after player. And then, not actually sure why that one didn't show up there yet. Oh, do I have a syntax error? No, that's an old one. Curious. Oh well. Real quick, while I'm thinking about it, let's go to tick. And at the end of tick, we're going to update lives to be the current player's lives. So if we lose lives or something during that tick, it'll happen. Oh, there it is. Weird that didn't show up earlier. Might not be ready at the first one. Okay, so we got our lives. So let's add our score now. So our score, if you remember, we made this text for it. So we're going to show that, and then we're going to show numbers next to it, and I think that might be kind of huge, but we'll see. So we're going to have kind of a two-parter here. So let's go ahead and we'll make a score sprite, and this guy going to extend regular sprite, and what we're going to do is this guy's going to have 2 sprites inside of it, our image sprite and our text sprite with our score value. So let's see, so we're going to have our score value, and then we're going to have our score text, and then we're also going to have our score image, but we don't need to save that off because once we add it once, we're good forever. And then let's do a static async load, and that's going to call, that's going to load our image. So this is going to be a lot like how GameSprite works. So this dot image equals await load image, and the URL is asset/score.png, I think. Nope. Oh, and you mark this guy static. There we go. And need to import this guy. Okay, so we have that, and then we'll have our create, and our create will just return a new score, and then we'll have our constructor, and our constructor is going to be what actually creates our two things and assigns it to ourselves. So first we'll create the oh, that's because I haven't finished this yet. We'll create the score, which is going to be an image sprite. Is this how I want to do it? Yeah. So we'll make this a variable here. Actually, we could do it that way, but I don't want to. That feels kind of lazy. Because I could technically reload the same image, and it's not going to hurt anything. But we'll just do it like this, because we already have the image available. So we create the score, we set it with that, and then for this guy, we want to position it on the right edge here. So we're going to have some amount of text here. So we'll leave a space for text, and then we're going to have our score here. And we want our score's right edge lined up with that text gap. So we're going to make the score's origin be still top for y, so still y, 0 for y, but we'll put the origin at score the width. That way it's on the right. That way we can put it at whatever our gap is, and it'll just be right lined up with that. So we'll do origin equals new vector, and so the x will be score dot image dot width, and we'll keep that as y, and then scores x will be well, we can leave those as 0 0 because the text plus the score text is actually this composite sprite, so we'll leave it at 0 0, and then we're going to have to position this composite sprite in the right spot. Which actually makes me realize that we need to give this guy an origin, and basically put it at the right edge too. So let's create a text width, let's say, I don't know, 200 pixels. We'll reserve 200 pixels. So the origin of this guy altogether is going to be score.image.width plus text width. So score.textWidth. So that's going to be, because that's going to be its width. So why don't we set that as its width? Width equals. And its height is going to be the height of the image, and we'll keep the text height equal to or less than that. And then this we can just do this dot width, and we'll keep it at 0 still. Okay. And then so score text or score image position there. It's x and y 0. Okay. So this dot add child score. Okay. And then actually we don't need that one because we're never going to update. Oh wait, yeah, no, that's actually our score number. And then our score text is going to be a new text sprite. And score text. Okay. And then this guy, so let's give it a font family. Actually, we'll stick with the default font family, which is Calibri, Arial, Helvetica, Sans Serif Stack. We'll do align. Let's see. So it defaults to align left, so that's good. We'll change its vertical line to middle. Yeah, because we'll want it to be centered horizontally with our score image, I think, or thereabouts. We'll do font size. So let's see, how big is our score image? So if you mouse over it, she'll show. So it's 68 pixels tall. So we'll do. Let's make it roughly as tall as the smaller letters. So that's probably in the neighborhood of 40. And actually, now that I look at that, let's line it up with the bottom of it. So that way, like, the S will be above everything else, and we'll have our score there. Okay. Which means score text.y is going to equal score image.height. And I'll put it at the bottom. Yeah, as for the text one, because the text is all dynamically generated, and you can't really measure it ahead of time, the vertical and horizontal lines kind of act very similar to how we've been using origin, except we really only have 3 points. We have left, right, center, and then we could shift it if we wanted, but we don't want to. Or actually, we do want to. So our x is going to be score.image.width plus some padding. Let's try 10. So just we have a little gap so they're not smushed right next to one another. And then this dot add child score text. And this dot score text equals score text. Okay, so we got that. And then what we're going to do is we're going to come here and we're going to add a getter and setter for the score number, because when we're given a value, we're going to update score text to be that value. And actually, we don't even need to keep, well, yeah, I don't think we need a getter, and I don't think we need that value. If I'm wrong, we can always come back and change that. Okay, so that might be good. So let's come load it. That one it actually figured out. Okay, and then we'll just create one of those. So this one we will need to keep. So score. And this one we need to keep track of the number, and we need to keep the sprite itself. So score sprite equals score.create. And then this guy's origin is on the right, so we're just going to set its x equal to root sprite dot width minus 10. So we'll get 10 pixels of padding on the right side when the text is at its full width, which actually is probably a pretty high score. And then y, we're just going to set to 10, set 10 away from the top. And that should be all we need for that. Oh, and score sprite equals score sprite. And then we'll go to our tick real quick. And just like our lives, each tick we're going to update the score value. And real quick, just like we did with player, let's implement a reset method in here for the same reason we did with player, to reset all of these things to their initial values for the things that move. So those won't move. Player will move. So we'll do player and delete that. And this dot player, root sprite equals this. Okay, and then we'll call reset down here. Yes. And score is another one we want to reset. So this dot score equals 0. And we'll call this dot player dot reset here, so I'll reset everything in the player. I think that's... Oh, and we need to... So if like we leave the screen and we have any bullets still on screen, we want to remove all those bullets. Children, and I have a remove children function that removes everything in an array. So we'll remove everything in that array, and then we just set bullets, so we clear it out. So that's like if we get game over, we may have bullets in the air when we get hit last, and so when we hit play again and come back, we want it to reset to the beginning. Okay, and things blew up. Alright, what did I do? Oh, I know what I did, I bet. Score. I changed where... No. Yes. Changed that around and then changed it back, but then didn't change it back all the way. Okay, and this dot reset is not a function. Oh, because we need a pound on that. Because I made it private. There. Okay, score. Is it stretched out? It is definitely stretched out. Oh, it's stretched out because normally when we load the things, we use that create from URL. It calls this, which will size the sprite to equal the image. So there we go. Okay. That's still really big. Oh, right. We do need to adjust the X because we need to make room for the text width. So we'll do... So the width of the whole thing is basically this thing plus the text width if it's right aligned. Actually, it doesn't even, we don't even need to right align it actually, because if we don't right align it, then everything else lines up just fine. So let's not even change origin, not change X, and then we should be happy. Or we could be the opposite of happy. Why did that do that? That's weird. It should be origin 0, X 0, and then your width. Alright, so let's output this and look at our numbers. Okay, so let's check its width and height first. So its width is 403. So that should be image plus 10 plus text. So this is 203. I did forget to add plus 10, but otherwise we were pretty much right. Let's just add plus 10 down here for that padding. Because remember, we added that padding in there. Okay, so that's otherwise right. Height is right. Okay, so now let's look at children. So the image sprite should be 0, 0. So this is our image. And then origin 0, 0, 0, 0. Okay, so that's all right. Because that should be the top left of our parent. And then we have our self. Alright, so, okay. This number is wrong. So our screen's only 800, so we're subtracting 10. Oh, did we... No, we did change our origin. So our origin should be our width. Should actually be right, I think. No, no, wait. Our X should be... Man. Is this right? So, got our box, got our screen. We have this guy. Its origin is over on this side. So, if I say move it 10, should be like that. There's something messed up in my math here. Let's see. Render manager. Or not render manager. Sprite. Sprite manages. So we translate it by X and Y first. So we move it. So it's X in this case. So we got, delete all that. Okay, so we got, alright, so this is RW. This is RY. Let me grab my tablet because I can't write with the mouse. Okay, and then we have SW, SY, S.X, S.Y. I'm just going to say O.X. It belongs to S though. Okay, so translate it by X, which is 790, so it should be there. Then we should shift it back, origin. Should end up like that. Huh. Your X and Y should be 0 and your origin should be 0. We should probably change that to clicking instead of spacebar. Vector with getting tired. Maybe about time to call it night. Origin. If you're 0 and you have a width of that, with your origin is that. Alright, I want to try something just for diagnostic sake. I want to see what it does if I put that as negative. Didn't move it one iota. Interesting. Oh, you know what? I wonder if yeah, that's what it is. I'm reverting the origin before I render the children. Really, all of this should be done in one clump, I believe. Everything goes crazy. Nope. That actually kind of worked, although why are you way down there? Okay. So, let's go look. It looks like I may have accidentally did a Y instead of an X here. Oh, I forgot this guy needs his origin set to be no, because it's bottom. Image height should align with the bottom. I need to set this guy's height equal to its font size, which is 40. And it's still pretty off. Guess I do need to actually set its origin too, don't I? Left is fine for that, and then this should be 40. Here we go. And it's too small. Let's bump it up, which actually, since it's now in 3 places, let's make it a variable. Actually, we don't need a set height. Actually, maybe we do. We do. And tiny bit more, and let's actually get it to line up with the colon. So actually, maybe we won't even move it a little more. So let's see, instead of y, so minus 10. Let's see. Actually, maybe we will size it with that as, because it looks a little funky like that. So let's go, S was 68, let's go tiny bit smaller, 65, and then we shouldn't need that bit. There we go, that doesn't look too bad. And let's change the color. And let's just go with that green. That score is eyedropper. Gotta kind of get in the middle there, like that. Alright, so it's this color. There we go. That's not too bad. Alright, and let's change this to click, because I keep clicking instead of spacebar. Click, I think, is much more intuitive. Clicky, clicky. So, instead of, where are we? Player fire. Instead of space, and instead of key, is mouse down. There we go. Now I can click. That feels a lot more natural. Yeah, that seems pretty good. Okay. So now, time for the zombies. But, oh, actually. So we gave it that room, so the score has room to grow, but it's a lot of space. So we could do 2 things. We could either shrink it, but then if your score gets higher, or we can pad this with zeros to make it always fill up that space. It's actually what a lot of arcade games tend to do. So let's go with that approach. So what we'll do, let's make a new util function real quick called, we'll do pad, but actually we want to make pad before. So the first is the value, the second will be the length, and the third will be the padding, which will default to O. Okay, and then there's a bajillion ways to write these. One nice little quick, easy, one-line way to do it is you can create an array of length and then fill it with padding, and then join that with nothing. So this basically creates padding of total length, but we want this, and then we add that to value. So now we have, like, so say we want it to be 8 characters total. We make a string of 8 characters. Is that 8? Yeah. And then we add something else we want. And then we do negative, a slice of negative whatever length we want. And I'll take, starting from the back, 8 characters. So that's how this guy works. Dot slice negative length. And while we're here, why don't we go ahead and just implement the other way around, just regular pad. And it is, as you might guess, virtually identical. The only difference is we move value to the front, and instead of doing negative, we do 0 endlings. So we start from the beginning and we get those. Okay, and then let's go to score. And so we're always going to do pad before. And let's try 8 characters. I don't know if that's going to be too long or not long enough. 1, 2, 3, 4, 5, 6, but we don't quite have room for 6. So let's actually shrink the score down a little bit and we'll say 6, and that'll probably be good. So the font, so 6, and let's go try 60. I don't think they'll give us... okay, that looks pretty good. So that gives us 6 digits to play with. So if we do maybe 10 a kill, then that's a really high score. So should be plenty of room. Okay. And I think, it's been bugging me for a bit, I think the player is just too big for this playfield. So let's go and let's shrink down both our player and our... Where are you? Oh. Shrink down our player and our zombie. Oh, what'd you do? Transform. Hold Alt, aim. Yeah, let's try that. Shrink our player to roughly the same size. Oh, there we go. Select, darn you. Oh, it is trying to transform the whole thing. Why are you doing that? Stupid thing. Control D, Control T. There we go. That was way more effort than it was worth. And trying to get the heads about the same size. Well, there's good, I think. Alright, and luckily everything's dynamic, so, except for origin. So, let's remeasure origin for the player. If you remember, we opened it up and we took a ruler and we got the point, since it's a little tricky to get math-wise, so we'll just... And actually, why don't we get it math-wise this time, though, in case we decide we want to change the size again. Where's ruler? So, right about there. Okay, so I'm looking at the x and y value. We got 31, 35. So, if we scale it, it's always going to be proportionate to the overall width. So what we'll do is we'll take 31 divided by its width, which is 62. So, literally the middle in that case, by coincidence. So we'll do player.image divide.width divide by 2, and its y is 35 divided by 55, which, let's open up calc. 35 divided by 55 is 0.63 repeating, so we'll say 636. And that gives us plenty of pixels, or plenty of precision when we're dealing with pixels, times 0.636. Okay. There we go. So now, yeah, looks good. Okay. Now he feels really tiny, but actually I think he fits better, because if you imagine this is sidewalk, sidewalk's usually 2 people wide, so yeah, I think that feels better. They'll also let us get a lot more zombies on screen at once. Whee! Okay. So, alright, so let's think about our zombies for a second. So, how we want our zombies to move is... So, they'll come from anywhere along the edges, and we're going to want them to aim towards our player and move towards the player. So, just like, pretty much every zombie game ever, all those zombies will be moving towards us. So, once again, that means we need a little bit of trig. So, we got I lost my walking pin. What do I do with it? There it is. Okay, so if we imagine, well, we don't need a box. So we have our player, and we have our zombie. Each one of them has an X and Y. And we can use those. Good old Pythagoras. So, pretty much just like we did our other two things that involved trig. The only difference is now we have 2 points instead of knowing X and Y already, but we just take player X and Y versus zombie X and Y. And we get, oh, I have some users. Hello, guys. So, for a zombie guy, so calculate this guy we're going to do, so this width is just zombie.x minus player.x, and it doesn't actually matter if I do this one or this one because we're going to absolute value them, because we want the difference between them, not necessarily which one's first or second. And then this guy's just y minus player.y. And then once we have those two numbers, then we can use our cosine and sine to aim them. Or actually, yeah, so that'll be for our velocity, and then our rotation will be tan again. Tan of those two things. So, pretty much the same thing we've done, just getting numbers a little bit different. Okay, so first, let's go ahead, just like we've done for our other things, make a new class, zombie, export default class, zombie extends GameSprite. Okay, we're going to set our GameSprite URL to be asset zombie.png. And so for our zombies, as far as them moving, we're going to do them just like the bullet. They're just going to go full speed all the time. So we're only going to give them a max velocity. And we'll start with 500. We're not going to give them friction. They're just going to keep moving towards us. If they touch us, we're just going to die somehow. Or they're just going to die. We're going to pretend somehow we take damage if they hit us, but we also disintegrate the zombie because we're wearing disintegrating zombie armor or something. I don't know. Don't ask questions. So got that. So that should be pretty much it. GameSprite already has a rotation and all those properties built in. So let's come in here, and actually we won't set this in here. So really, that's that whole class there. Because we'll make our zombies move at different speeds. That way not every single zombie's moving exactly the same. So let's come down here. Alright, so let's go to our tick function. We'll just make a new function here. So we're going to have two zombie related functions. We're going to have a zombie create, because we're going to randomly spawn new zombies. And then we're also going to have a zombie move to move the zombies we have created. And then let's go up here. Let's make some values. So we're going to have our zombies array to keep track of our zombies. Then let's create a zombie chance variable, and we'll make this be the average number of zombies spawned per second. So our zombies for now, we'll just make them so they'll take one shot to kill. So that means we want to have a steady stream of zombies. If we were to give zombies health, so it took multiple shots to take them down, which is something we could do later maybe. We might not want to create 2 zombies a second, but for now with 1 shot each, and we'll start with that. And then we'll do zombie min velocity. So let's say maybe 100 pixels a second. And zombie max velocity, so maybe 500 pixels a second. And again, we'll just pick numbers, and then we can always play with them later and tweak them. So, got our values. Alright, so let's create these 2 functions. So I'm just going to go down here, and we'll put them here. Zombie create, zombie move. And I'm going to implement zombie move first because it's just super easy. It's exactly like bullets. Zombie.move since last. And then our move function will take care of the math to deal with the velocity and make them move properly. Okay. So, we'll start out with an if. So if, let's see, how do we want to do this? If zombie chance, and actually let's make those private variables. And actually let's also put these values in the reset down here. Because again, we might want to play with those during the game. Like maybe we want to make zombies spawn faster as you go, or make them move faster as like the game goes on or something. So we'll implement them down here in the reset, so that way if we ever change them, they'll get reset back, and we don't forget about that. Okay, so if our zombie, so we'll do math.random, so we'll generate a random number. JavaScript's version, it generates a number between 0 and 1, so basically like a percentage chance. So if this number is greater than this dot zombie chance times since last divided by 1,000. So again, zombie chance is a number of zombies per second on average, because we have some randomness in here. But because since we're not going to wait a whole second, so since last will give us what percentage. So it basically it adjusts our percentage to what fraction of a second we have. So should work out roughly to an average of zombie chance number of zombies a second. And so if that's true, that means we're making a zombie. So let's make a zombie. Equal zombie.create. So we'll create one. Import this. Okay. And then, so we want to set, oh, actually I just realized we need to rotate zombies here. Okay. So we'll actually not worry about moving. Yeah, because for these guys, we actually, every second we want to move. We want our zombie to move, and we want them, if we've moved, we want them to rotate towards our new position. So when we create a zombie, really we'll pick a max velocity for it. So we will actually set a velocity on here, since the actual velocity xy is going to change constantly. So we'll set a, we'll call it total velocity, I think. Total velocity. Because total velocity makes more sense than max velocity, because they're always going to move at that velocity. Okay, so we're just going to randomly pick the zombie's total velocity. So we want it in between our min and our max values. So we'll do math.random times this dot zombie min velocity minus this dot zombie max velocity. And then, no, backwards. Max min plus this dot zombie min velocity. And that's how we get a number a random number between 2 points. Is you do the difference between the min and max, and then you add the minimum. And so like if our numbers were 10 min and 100 max, we would always get at least 10, because if this was 0, this whole thing would be 0, so we'd just get 10. Or if this was 1, we would get 100 minus 10 is 90, plus 10 is 100, so we'd get 100. Actually, I don't remember. JavaScript's randoms might not actually ever hit 1. Let's Google that real quick. dm.random might be like 9999999, but never quite hit 1, but I don't remember. Math.random. Okay, yes. So it is inclusive 0, but not 1. So yeah, so you might get 0.999999999, but you won't ever actually get 1. But for our purposes, it doesn't really matter. We're talking a difference of like 0.00001, less than that difference. So set the total velocity. Now we add it to our zombies array. And again, I like to do functional programming when I can. So we'll do functional styles. So we'll create a new array and add it to that instead of doing a push. And then we're going to add this to the root sprite so it'll actually show up. Zombie. Okay, and then one more thing. We need to decide its position. So we want the zombie randomly positioned around us. We have two ways we could go about that. One way is we could simply do like one random between like 0 and 3 or well, 0 and 4. So we'd have like, we could say this is side 0, 1, 2, 3. Based on that side, we would then pick a value and put it somewhere there. Or what we're going to actually do is we're going to imagine a circle and we're going to say they always spawn a certain distance away, and we'll make that distance be half of our, that like if we were here, we would put it here or here. And then we want a circle, so really if they're top and bottom, they spawn out a little further, but that's okay. So we'll just pick a random angle, and then we'll put them that distance, that angle away from us. Some more trig, yay! All the trig. Let's wrap that. So we'll say, let's create it up here because I like to group my variable creation together when it makes sense. So we'll say distance equal, or no, sorry, not distance. We're generating an angle. And so just like our speed calculation, except this time it's between 0 and 2 pi, and since 0 is our min, we don't have to do any math because the zeros all cancel out, so it's literally just math.random times 2 times math.pi. So that'll give us an angle, or yeah, that'll give us an angle, and then our distance is going to be half the width of the screen plus the zombies width. That way they always spawn off screen no matter which way they end up. So let's put zombie.x equal, and we do need to set its origin, which that we'll actually put here because every zombie will have the same origin. And its origin, just like our player, is going to be based on the middle of its head. So let's do what we did for our player. We'll calculate the middle of its head. So about there maybe. So looking at the x and y, we got 28 and 41. And then let's do that as a proportion of its overall. So what did I just say? 28. So exactly half again. 56. So x is zombie.image.width divided by 2, and its y is going to be 41. Let's see, 41 divided by 63. So 651, we'll say. So zombie.image.height, and I misspelled zombie over there. And what did I just say? 651. 651. Zombie. There we go. Okay. So all zombies have the same origin. And then back to our game scene. So its x is going to be, and we'll go ahead and get distance here, which is just going to be this dot root sprite dot width divided by 2 plus zombie dot width. And really that's going to be a little further out from the screen than it has to be, but again, that's okay because zombies can come at all different speeds and stuff. Okay, so let's see, more trig. So let's just draw this out real quick. It's always easier to program trig if you draw it out. Alright, got my tablet. Okay, so we're always going, we'll spawn it, I don't know, we could use the player as the origin, or we could use the middle of the scene as the origin. Let's just use the middle of the scene as the origin for now. So we'll say middle of the scene. So that would be basically, whoops, root root sprite dot width divided by 2 and root sprite dot height divided by 2. Okay, and then the zombie. So we have, in this case, we know an angle. So we'll say the angle is relative to that. So we know this angle here, which is zombie theta. And then we know this distance, zombie distance. And we want to find this x and y. So if we blah 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 blah, does that give, does, I think it might actually be cosine theta times d actually might give it to us, and then sine theta, maybe. It's always some combination of cosine and sine. Pick one, figure out which one it is, or try one. If it's backwards, you flip them around. If one of them's going the wrong direction, you make them negative. So do distance times math cosine rad zombie.y equals distance times math.sine rad. And I'm actually, it would be dot root sprite dot width divided by 2 plus that. And this dot root sprite dot height divided by 2 plus that. And to test this, because they're not moving yet, we want, and if we're wrong, they may move forever off screen, and that would be annoying. So I'm just going to short circuit it real quick, and I'm going to make distance just be like 50 pixels from the center, so we can tell if it ended up where we want it to be. So we should be able to see this unless it like ended up way crazy off. And I'm going to console on zombie so we can look at what the, we need output the rad. So we can look at the rad and see if it should be. And this one should be oriented so that 0 is to the right, like normal Cartesian coordinates, and then we go that way. So let's see if we got it right. Probably not. Cannot read width of undefined. Did I add zombies to load? No, I didn't. Here we go. Zombie.load. Okay. And then might be spawning zombies a little quickly. So did I get those numbers backwards? Since last divided by that. No? Zombie chant. Oh, well, 2 a second. I guess that is that fast. Let's lower that down a little bit for now. That might still be a good number once they take some time to get closer to us, but for now that's a little quick. Let's go with that. Alright, that's definitely more than 0.1 zombie a second. Yeah, I goofed here. Less than. I was doing the opposite way, so if I wanted a like 0.1 chance to spawn a zombie, I was giving it a 99.1% chance to spawn a zombie. Alright, and that's probably too slow now. Let's go back to 1. Let's go back to 0.1 for now, because I only want to spawn like 1 zombie so we can investigate it. Come on, zombie. Spawn. Yeah, and this is the thing with random chance. Sometimes we'll get like a bunch, and then other times we won't get any. Okay, so should be, so this would be pi, so maybe about 5/4 pi. So that'd be half pi. Yeah. So what did we calculate? We calculated what's that, about 3/4 pi ish. So 3/4 pi should have put him here. So we might be rotating the wrong way. So let's go negative. And really, honestly, it doesn't super duper crazy matter, but I like to get it lined up how I mentally expect it to be because that'll help avoid bugs down the line if, annoying things happen. Okay, so first zombie is about 3/4 pi and negative 2. Oh, wait, actually, I didn't mean to negative that. I meant to negative these guys. One of these. That one, I think. Okay, so that's about almost pi, maybe 3/4 pi. Okay, so I think that's about right now. Yeah, so that would be about 1/4 pi. Yeah. Okay, cool. So I think we're good now with our positioning here. So that should be good for spawning. So now we'll crank and the distance seems good. They're spawning in a nice circle around the origin of the map, so distance portion seems to be working fine. So now I'll put this distance back here, so now they'll spawn out off screen initially, and then we'll crank this back up to 2. Now let's go for zombie move. So zombie move, I said it was super simple. It has some trig, so it's as simple as you think trig is. So we want to do 2 things here. First, we need to get our zombie rotated to face our player. Then we need to change our velocity so that it is just like our bullet was, the total velocity of the x and y direction add up to be the velocity we want it moving at. So first let's rotate it. So back to drawing, because drawing makes trig easier. So we got, shouldn't have deleted it. We got player, stop hitting buttons, zombie, this absolute of zombie x minus player x, this absolute of zombie y minus player y, and then we want basically this angle, really, I guess. So we should be able to use atan 2 of those numbers to get it facing right. And actually, let's go back real quick. Oop, don't leave pen sitting on Wacom tablet. It takes over your mouse. Alright, so let's pop our distance back here, back to 50. So they'll spawn near us. So if we get our direction right, they'll all be in a circle facing us. Not intimidating at all. Zombie.rotation equals math.atan2. And this would be zombie.y minus this dot player.y, and zombie.x minus this dot player.x. And I said absolute value, but now that yeah, there's yeah, no. Yeah, they should not be. No, they should be. That's right. Not absolute value. Alright. They're creating a circle, but we're off 90 degrees, which makes sense because we have our player oriented 90 degrees from normal Cartesian. So, and our zombie. So let's minus half math pi to turn them 90 degrees. Let's see what that gives us. There we go. Now they all want to give us hugs. Look at that. Cool. So get our direction. Now we just need to adjust our velocity. And now that I think about it, I kind of wish I'd made velocity 1 value and then use that to take rotation into account. I may change the game engine later, but let's not do that right now. But that'll make things easier because then you'd put 100 velocity and it would figure out the x and y components of that. But x and y components shouldn't be too hard. It's the whole multiply things by cosine and sine, and like I said earlier, it's always some combination of them. Try one. If we get it wrong, we'll just flip things around. So, let's scooch them out just a little bit further so we can, because if they're right on top of us, they'll get to us in a spin and we won't be able to tell if they're moving the right direction. So we'll move them out a little bit, but we won't move them off screen just yet because I want to keep an eye on them. I don't trust our zombies. So total velocity times, and let's try cosine here, of its rotation, because we want it moving forward relative to its perspective. And I feel like I have those backwards, and one of them needs to be next. That's a nice shape. They're circling. Oh, no. Okay, so they're backwards. So sine, cosine. They're flying away. So I think they're moving right in the x direction, wrong in the y direction. Yay, there we go. Lots of hugs, and they are moving really fast. We may need to slow them down. It's more like runner speed. Cool. And let's see if they follow us. They should just create like a mass that stays on top of us. I can't get away. Oh, I'm faster than some of them. Ah. Oh yeah, we should make it so we can't go off screen. I have a giant like centipede of zombies. It's kind of fun. Okay, cool. So now their math is working right. They are way too fast. So let's put our distance back. So now they should spawn off screen. Okay, they are way, way, way too fast. So let's go turn that way down. I think maybe 200 max, and those are our runners. And let's see, these are zombies. They're half dead. Let's try 20. We want kind of a little slow lumbering, and that is still a lot of zombies. Okay, yeah. Okay, that's not bad, but too many zombies. Let's crank that, or let's turn that down to 1. Okay, there we go. The nice thing with this too is because they're different distances away, some of the zombies may be like walking for a while, so you may think that you're like safe, and then suddenly a whole bunch of zombies end up coming from one side of the screen for you. Okay, cool. So now, alright, so now we got our stuff going. Let's actually tweak our background real quick, just because we don't want to go off the edge of the screen. So let's make it so it looks like there's a reason we can't go off the edge of the screen. Well, although we want zombies to come in. Yeah, screw realism. Let's say, we won't change our background. We'll just keep ourselves on the, we'll keep ourselves on the screen, but, no. Let's not even worry about that right now. Shooting zombies is more important than not being able to go 8 miles off screen. Plus, you can tell where you are because of the trail of zombies following you. Okay, so let's be able to kill some zombies. So, basically now what we want to do is whenever a bullet collides with a zombie, we want the zombie to die, the bullet to get destroyed, and to give us a score. So, let's go up here, and we're going to do this dot, we'll call it resolve collisions. And we don't need since last for that. Alright, make a new function, resolve collisions. Okay, so now we'll basically just loop through our zombies, and then we'll loop through we'll find the bullet that hit the zombie. And now technically multiple bullets may manage to hit the zombie simultaneously. We're just going to take the first one and call it good. So we'll say bullet equals, and then we'll go bullets.find bullet, and then so our sprite class has, sprite extends rectangle, and rectangle has hit rect. It has hit point, hit rect, and hit ray. So hit rect lets you tell if two rectangles are overlapping, so that's the one we're going to use because both our bullet and zombies are rectangles. So if bullet.hitRect zombie. So if we have a bullet here, that means we found a bullet that hit the zombie. So we're going to destroy the zombie, the bullet, and give ourselves a score. So let's make a function real quick called destroy from sprite array. Cat, I think, just stole my walking pin. He did. Okay. Okay. So this will be so to destroy it, we need to find it in the array first. Index of index. If index equals 0, it's not in there, so we're just going to return the sprite array, and we'll pretend we've removed it. Not index there, sprite. And if we did find it, we're going to return, we need to first remove the sprite from its parent. So all sprites know what their parent are, and then we'll do remove child sprite. So move it from the parent. The parent's probably root sprite. In our case here, it's always root sprite, but we want this function to be nice and generic, so just in case it's not root sprite, this will take care of it. And then we'll return sprite array sliced with that bit out. And that will let us, and that delete it from the array. So just to show what that's doing real quick, like if I want to remove if I want to remove 3 out of there, so the index of 3 is 2, and then if I do a dot slice 0 index or 0 2, and then a dot slice 3, so 2 plus 1, I get everything before the 3 and everything after the 3 and make a new array out of that. So that's what I'm doing here, just with sprites. Okay, so here we got destroy from, so we'll destroy the bullet from the bullets array. And we have to actually set it back to this, so we update the bullets array. And again, that's because I'm doing it a functional way instead of updating zombies, which pros and cons to that might come back and bite me later, but for now, that's what I've decided to do, so I'm sticking with it. Okay, so we got bullets, zombies destroyed, and then we'll give ourselves some points. So score, and let's say 10. Zombies are worth 10 points. Maybe down the line we'll implement multiple zombies. So try this. And we blew up. Awesome. Sprite.parent.remove. Cannot read property. Hey, that's curious. Hang on a sec. Their parent's not being set properly. Give me a zombie. Bullet. Parent is null. Curious, because that child should have set their parent. Huh. Child.parent. Yeah. Oh, because I'm doing insert before, and insert before doesn't set their parent. There we go. Pew. There we go. So both of those got destroyed. I got points. Pew, 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 pew. Okay, so right now I'm invincible because zombies don't hurt me. So let's go make them hurt me for some reason. Okay, so if we find a bullet, we're going to stop there because this zombie we're looking at is dead. If we don't find a bullet, though, let's see if it hit us. So player.hitRect zombie. So if zombie and us hit, we're still going to destroy the zombie because, again, as mentioned earlier, somehow we take damage, but we have zombie disintegrating armor. And we're going to lose a life. So player.lives minus minus. And we don't get a score or anything, so that should do the trick. Okay, so now, if that part works right, then when we get hit, our score will go down, or lives will go down. It does not, and the zombies aren't dying either. Why? Oh, wait. We might have a compile error. We do. This dot zombies. Yeah, so that code we just wrote didn't go into effect because we had a compile error there. Alright, let's get some zombie hugs. There we go. Perfect. Yay. Alright, so now technically we're dead, but somehow we're still alive. We don't know we're dead yet. Okay. So now, last thing, let's make us realize we're dead. So we'll come back to our tick here, and we'll do if this dot player dot lives less than or equal to 0. And we do less than or equal to because while we should end the game at 0, it's technically possible, like if two zombies hit us at exactly the same moment, we may have 1 health and lose 2 in 1 tick, so we may end up -1 lives or something. So just to be safe, we'll do negative or less than equal to 0. So if this happens, we're going to do this dot engine dot scene manager dot change to game over, which we haven't made that yet, so we're going to make that real quick. And we also want to do engine dot data manager dot set score. So data manager just lets us put arbitrary data in there, and that data can be accessed between scenes because normally only one normally all the scene stuff is self-contained, but data manager can cross between them to share scores, so that way we can display our final score on the game over screen. So we have our score there. Okay, so let's make our game over scene real quick. So let's go here, make a new scene, game over scene. Okay, export default class, game over scene, extend scene. This one's going to be very similar to our start scene. In fact, it's going to be so similar, I'm going to cheat and I'm going to copy paste everything. And then we'll just tweak the stuff we need to. So this won't be title anymore, this will be game over. And we need to go make this image, game over. And we'll position it roughly the same. We may tweak it once we get the game over in place because it might be a different size. Our start button will be our play again button. And these are going to be play again, play again, play again. And really I should have used the refactor feature. Refactor rename, play again button. That renames all of them for me. And this is the game over. And then we're good there. So if we hit play again, it'll go back to the game. And actually one more thing before we hop off, or I guess we can do after. We'll go ahead and call reset. That way when we come back from game over, we've already reset and we're good to go again. Okay, and then we just need to register our scene over here. Game over, and we only use scene manager for that guy. Okay, and then we need to import it. Make sure we import the right one. Okay, and oh yeah, we gotta go make our game over and our play graphics. So let's just find some clear space and lock that so I don't screw it up. Make a new layer. So this will be game over.png. Alright, so let's take, why don't we go red this time because we're dead. We are zombie food at this point. Let's go kind of a darkish red. And let's get a little redder. What? Nope. And about there, maybe. Okay, and game over. Why not? We have some very high quality rendered blood drips right here going on. Okay, so got our game over image. Now we'll do our so for our play again buttons, I'm going to cheat. I'm going to take these 3 guys, I'm going to duplicate them, unlock them, move them, down here, then let's rename them. So play again active, or play again button active.png. Is that what I had them here? Game over, play again. Yes, okay. And play again hover button. That needs to be, whoop, nope. Come back. Play again active button. And play again button. Okay, and let's open our up. Swap out the text. Hit something and now my library's auto-collapsing. I don't like it. Layers. Stay up. Okay. Okay. So instead of start, play again. And it's too big to fit on that button. I'm going to shrink the text down. Recenter. Okay. Play again. Shrink the text. Center it again. Play again. And center. And then let's go ahead. Swap our colors out here for red. I've been doing that with the hue saturation changer, but we'll do this with blending options. So we already have one on. So color overlay, and why don't we just eyedropper that? And copy layer style. No, we can't do that because they have different drop shadow settings, so we can't copy them and paste them. So we'll just do that. Well, eyedropper that. And nope. Eyedropper that. Okay, there we go. So now we should play again. Oh, I did name them weird. Play again. What did I name? How did I name the start ones? Okay. So I did actually put the word button before hover. So we'll stick with that. Hover. And actually, I kind of like that better anyways. Okay. Save. Actually, that reminds me. I want to see. Okay, good. I didn't know if Photoshop deleted old ones or not. It does. That's nice. Okay, so time to die. 1. Give me hugs. 2, 3, 4, 5. Game over. Perfect. Play again. Oh, I don't know if you caught that. Let's get up to speed. Oh, and actually we forget to reset our zombies too. But I'm trying to be at speed while I die so you can see the other bug. Yeah. Harder than it looks. Run headlong into some stuff. But if you notice, as soon as I come in and play again, I'm still actually moving because I'm not forgot to reset my velocity back down to 0. So for player, it's reset. Let's get its velocity and acceleration back to 0. Actually, new vectors. Trying to remember to use vector instead of creating pojos. For the most part, it works fine, but if I have something on the method on the vector and I try to use it in, but I have a pojo, that'll create issues. So better to use the vectors. Okay, so that'll reset that, and then we have to go reset the zombies and kill all the zombies when we die. We blow up and we take them all with us, as it should be. Zombies. Zombies. Okay. Alrighty. So now let's die, and let's see if we can die while I'm moving. Okay, and good. So no movement and no zombies. Although I was taking damage there. Oh, right. I removed the zombies, but I didn't clear out the zombie array, so I made invisible zombies. Because that's totally what you want to have, because zombies aren't bad enough. Alright, let's try this again. Let's make sure we try to die while we have a bunch of zombies on screen, so we can make sure there's no invisible zombies. Okay. Alright, not taking any extra hits, so no invisible zombies. And there we go. So we can still go off screen, but I'm tempted to leave that because I kind of like it. Oh, we got hit by a zombie off screen. So now I can shoot, and let's use the gamepad after I die. Come on, gamepad. Wakey wakey. Alright. So now I can control my zombie with my gamepad. Actually, those controls feel pretty good. So left stick moves, right stick aims, and I aim in the direction that I oh yeah, I forgot I added auto fire. Are we? Oh, I just realized. If you notice, our bullet is a lot further away from our gun now. We shrunk down, but that was some value we hard coded instead of making proportionate. So let's go fix that so our bullet is coming out of our gun. So that's in here where we create bullets. So player fire. Okay, so before we picked we just made up a number. Let's use a percentage this time. How tall were we? I think we were. Actually, I have no clue how tall we were. Let's try. Let's see. This would be the distance from 0 to us, or the origin to us. The origin to the end of the gun. So yeah, probably about 0.5, maybe 0.7. Okay, and now that's a little off. If I spin real quick, I can see I'm too far down. They're more like coming out of my stomach. So let's go a little bigger, I think. Let's see, 7, I think. Hard to tell. Actually, one easy way to tell is we'll just put them on top of us again. That's how we did it before. They show up on top of the gun, we can tell exactly where they come out. Okay, yeah. We're using mine bullets. We don't want mine bullets. I think I need to make the numbers smaller. Nope, still mine bullets. Oh, because... No, wait. Yeah, I need to be doing player.width times this number. And height. And both of these numbers are based on the height. Okay, so that's close. Let's make them smaller, question mark. I could sit here and do math and figure it out, but no, bigger. Okay, so I was right the first time. It is the difference between the origin and our bullet. Should be less than 0.5. Let's see. There we go. That's not bad. Scoot you back just a tiny bit. I want it to be like just under the barrel of the gun. Okay, that looks pretty good. That looks like it's kind of firing right at the edge. Okay, so we'll go with that. And then let's just swap these back around so they're underneath the gun again. Okay, cool. Hang on a sec. Just realized. Okay. Okay, sorry. Um, yeah, hopefully no one's saying anything in the chat room because I'm not seeing it. If you're saying something in the chat room, I apologize, but it's not showing up right now for some reason. Okay. Anyways, by the way, hi to the people that just joined. Um, okay. So I think we're actually pretty good. Not sure how long I've been streaming for at this point, but I do know my throat is pretty sore, so I think this is probably a pretty good place to call it a night. It is 11 o'clock as well. I think I said, oh, it might be time to wrap it up at like 9. Um, so I'll get this code pushed up as is to um, my website or to GitHub, and you can get to GitHub from my website or get to my GitHub from the website. I think I have it linked in here. Hopefully, maybe, possibly. I thought maybe I did. Maybe I don't. I should. Could have sworn I did. Weird. Well, URL it's chrisstreamingcode.com. Social, hit GitHub if you want the source code. So I'll post it there as is for now, and then I'll get it cleaned up, and get Zombie separated out into its own game. So just Space Shooter will be the demo with the code repo, and then I'll also get the engine itself publishing as an npm module. So if you wanted to play with it, you can pull it in. Uh, like I said earlier, the game engine isn't really like a full-fledged like production game engine that you would want to make apps with. It's a teaching tool first and foremost for me, so I can create these games like we just did. But it probably will evolve, and if you want to play around with it, it should be a nice like learning tool too. It's about the simplest game engine you'll find out there, so good to play around with if you want. And then and I haven't yet, but I'm going to get a Discord channel set up as well. So once I do, that'll be linked with these guys here too. Um, so yeah, thanks for joining. And hope you enjoyed. Hope you learned something. And yeah, bye everyone.